Good afternoon. Welcome to all of you. We are very happy to kickstart this afternoon. The AI Pulse conferences will take place all afternoon. Welcome here in the central stage, and welcome as well to everyone who is watching online. Thank you for tuning in today. So we're going to kickstart with a first panel discussion on artificial intelligence development to navigate through regulations. Big topic. For this panel, we have Suzanne Vergnolle, an associate professor in technology at the CNAM. We have Bertrand Pailhès, head of technology and innovation at the CNIL. And the panel will be moderated by Daphné Leprince-Ringuet, a reporter from Sifted. Thank you very much.
Hi, everyone. Is this on? Can everyone hear me? And welcome. My name is Daphne. I'm a French tech reporter for Sifted, based here in Paris. And it's lovely to meet you all. Today we'll be talking about regulation with this lovely panel that I will get to introduce themselves in just a second. But first, a question for the audience. Who here feels that they will be impacted in some way or the other by legislations, either rules that are already in place or some that will be in place, particularly vague and uncertain in the last few weeks, such as the AI Act, for example? Does anyone here feel like they might be impacted, them or their work or the model they're developing? Okay, great. Cool, you've come to the right place. As I said, we'll be talking about regulation in this panel. We won't be talking about regulation and whether we need it or not. I think actually we had a word on that in the keynote this morning. But we'll rather be talking about how, as a developer, as a business owner, as someone who's working in AI, you can adapt to regulations, to those that exist and to those that are coming that you don't really know yet. And to get it started, I'll make a point which was actually made to me by our panelists in our prep talk, so this is not my content, but I thought it was a good way to introduce the panel. And it is that just because a law doesn't carry the name AI, just because it's not the AI Act, basically, doesn't mean that it won't affect AI models. And by that, I think what the panelists meant is that there are already things that developers, machine learning engineers, data scientists should be thinking about now when they're building an AI model. And we'll be talking through these things and how to prepare for these things and tips and tricks to make sure that you are fully compliant with what is expected of you today. Of course, we will also talk about the elephant in the room, the AI Act, even though we've got somewhat of a changed timeline on that now. We'll discuss how you can prepare for the AI Act, and I think more importantly, as I mentioned, I think the bigger picture behind the AI Act being as technology evolves and as laws change, how can you prepare for a regulation that is ever evolving as well? So with that, I'll let the panel introduce themselves, starting with Suzanne at the very end.
So good afternoon, everyone. So I'm Suzanne. I'm an associate professor of technology law. So I teach all relating technology law topics, including law and policy of digital services, data protection law. And yeah, I do a lot of research focusing on the EU policy, including how to properly enforce DSA rules, GDPR rules, and so on.
Thanks, Suzanne. And Bertrand.
Hello, everyone. Good afternoon. So I'm Bertrand Pailhès. I'm the head of technology of innovation at the CNIL, which is the French Data Protection Authority. And I oversee the activities of the newly created AI department that we created to work on, especially on how GDPR and other legislation apply to AI systems, which are new system for us as well, even if we have seen them for quite a time now.
Thanks. So just a reminder that this is sort of a workshop format as well. So there will be time at the end for a Q&A and for you guys to ask questions about specific things that you want to find out from our panelists, specific tips that you'd like to get from them. But I'll get started right now with my first questions. That I'll preamble as such, and I think when we think about the things that developers and business leaders and decision makers in this field should be thinking about now rather than the future legislation. A helpful way to break this down is to think about what are the laws that affect all sectors and then what are the laws that might affect various verticals specifically. So if we start about the more general state of things across all models, what would you say are the key blocks, the key themes that decision makers in this space should be thinking about when they are building an AI model?
So yeah, AI is pretty much like any other tool. So basically, you need to look at what you're doing and think about what you're doing and what are the impacts of that to actually know which are the laws that are applying to you. And so basically, there are already a lot of existing laws that are applying to a lot of different tools. You all, like, we've been reading a lot on intellectual property laws applying to AI, or how do they apply? But there are like also data protection laws. In Europe, there is the famous GDPR. There is also consumer protection laws, competition laws. And so all of these, transversal omnibus topics can also apply to your business. So I think these are like the most various topic.
We were discussing earlier, you can add anti-discrimination laws, which is also laws that are very legal at this time, not with a big technical approach, but will certainly apply also to many cases where you can have discrimination, and an AI system will be used in that context. So HR, hiring people, credit scoring, that kind of thing.
Great, thanks. And we'll come to these blocks, I suppose, one by one. We have experts that are specifically experts in data protection here as well, so I think we might spend a bit more time on this. But before we get to data protection, could you give us a quick state of things on IP, which is the first block that you mentioned, and what are the kind of key things to think about in IP?
So maybe I'll start. I think IP is a sector where you have a lot of lobbying influence, and so that being said, we usually talk about the big tech lobbying, but we don't realize how much lobbying the IP sector has been doing for the past 100 years. When you look at the extension of the copyright limit Disney obtained in the 70s, you really can understand their influence. And so I think there is right now a lot of litigation pending in various jurisdictions, especially in the US. Last week, I think, a California judge dismissed lawsuits by artists and representations of artists on against notably Midjourney, where they said that there was no copyright infringement, so they had no claim. So there is this decision, but it's only one judge in California, but there is also a lot of other decision pending, and I think we will see a lot of litigation in the US, maybe a bit less in Europe, but we know there is also a big lobbying by institutions protecting authors in France, for instance, where you have a bill actually offering to better protect artists with AI. So there is a lot of uncertainty. My main key takeaway would be this: there is a lot of uncertainty on this field.
So basically, keep an eye out, but there isn't like a concrete set of laws already that you can refer to if you're building in that space. Unlike data protection, as you mentioned, so we do have the GDPR. That is a very specific law that you can refer to, and that is there to inform people in this space. Would you say that it is basically the key law that you should refer to? And Bertrand, I know the CNIL has sort of published guidelines around this, so maybe it would be useful if you run us through basically, the key things to keep in mind to navigate the GDPR today from an AI perspective.
Yes, thank you. Just to build on what Suzanne said, is for many AI, and when we talk about AI right now, we often think about generative AI. I think there is typically a difference between copyright material and data protection. For generative AI, it's obvious that having copyright material allows you to better perform. It's also true for data protection, but it's not as key as it is to access some protected copyright material. Would it be art, books, or actual code from GitHub or somewhere else. And we saw, I think what we saw in the ChatGPT investigation from our Italian counterparts in the beginning of the year, it's I was myself surprised to see that data protection issue rising so quickly, and even more quickly than copyright. And I think, but I also was convinced, and I think it's probably OpenAI would say that the risk at this stage are not that important regarding generative AI, because it's not the goal of the in the case of OpenAI, it's not the goal of OpenAI to target people. It's not they have personal data in their training data set, but they do not want to really exploit that data directly for the general purpose AI, and there can be use case of use of that general purpose AI that is aiming at targeting people, but still it's not like personalized advertising or social networks that where the key business model of the company is to target data to actual person. So that means that it's important, but it's normally you can manage that in many cases, and that's what we try to tell in our first guidance that we published a month ago, where we try to lift some of the risks that one may see in GDPR when training AI. So we focused our guidance right now on the processing of training AI, not deploying it, but just training AI. And we said a different thing. We said for general purpose AI, such as an LLM, for instance, we said that it's not problematic regarding the purpose limitation principle of GDPR, which is not obvious because the main idea of purpose limitation in GDPR is to limit the purpose, and it's typically the opposite of doing a general purpose AI. But we try to say that the purpose is a very broad notion in applying GDPR, and what I would say that you cannot be compliant with GDPR if you're your own purpose. If your purpose is to say, I want to do an AI because I want to do an AI. This is not a purpose in terms of GDPR. But obviously you can say, I want to do an AI that is aiming at discussing casually with people about everything, which is basically a large language model. You do not need to be very precise, but you need to have a goal, a purpose, and this is really one key principle of GDPR, that you need to process personal data only if you have a goal that you're able to, that is legitimate and determined. Perhaps the second aspect that I would cover two other aspects in our guidance, but there have been seven papers, guides, in English as well, so you can read that. And we will extend the consultation period for 1 month, so because it was ending yesterday, but actually you can answer later. The other aspect is how you cover data minimization principle, which is also in GDPR, and may also seem contradictory with the fact that you would need large-scale databases to train AI. What we said and what we see in the profession as a good practice also in the profession is that even for large-scale AI, people select and want to have a good quality databases to train their AI. And actually, this job of selection, this job typically for language model, the job to deduplicate the data, deduplicate the training data to avoid overfitting, to avoid overtraining of the data set of the model. All the action that you do to select the data in order to have a good performance is actually related to data minimization, in the sense that your purpose is to have to develop a large language model. So you need to have a large scale data, but you will also need to select that. And maybe if I have a catchphrase for that, is to say that data minimization is not to have little data, but to have clean data, to be able to know what is your data, what is your data about, are there personal data in there? Obviously, if there are not personal data, you're not concerned by GDPR. But and it's something that also comes of importance for IP, obviously, to know where the data come from. And I think if I take the example of the LLM, the fact that everybody's using as a basis common crawl is perhaps not completely good enough in terms of knowing exactly what is the data that I've been using to train my algorithm. And in the other range of at the opposite of the range, the work that Bloom has done, Big Science has done on the Bloom, we're trying to really label all the data that has been done is something more close to what is expected also for GDPR. And the last point, and I'll try to be shorter, is how we can reuse the data and reuse data that is available online. And it's something for which it was a bit difficult internally, because some of the people internally thought that, okay, if the data has been illegally collected, reuse it. It's like, I don't know English, recel en français. So like it's forbidden. It's also a criminal offense to reuse something that is illegal. And we came out with the idea that it may be a big stop to any kind of AI training to say that. And we ask now controllers to try to determine if it is manifestly illegal. And manifestly illegal means that it's typically data containing sensitive data in the sense of GDPR, health data, biometric data, and you're not sure that there have been explicit consent from the data subject. And and that is it should ring something in you saying maybe I shouldn't use that data at all. If I have health data coming from I don't know where, it's also a problem. If I reuse copyright data that I know, I reuse all the Marvel movies to train an AI, probably you should know that it's probably not completely licit, if you haven't talked to Marvel. And the same for instance, if you reuse data from data breaches, or data that has been leaked, probably it's also illegal data in the first place, and it's manifest that it's illegal data, and you cannot train an AI from that. I've been long.
No worries. And with the GDPR being such a key piece of legislation, it's important to get these things right. And I'll ask one last quick question on GDPR before we move on, because we're running out of time already. No, don't worry. Do you get sort of get out of jail card with these laws? So the idea that, you didn't know, you weren't aware, particularly if you're not, you mentioned the first case of working with personal data, but not necessarily having the aim of processing personal data. Do you get, especially as a startup, do you get that kind of leeway?
Technically, no. We're issuing guidance to guide, but also in order to enforce. We try to not enforce rules that we haven't made clear at first, because obviously it may be difficult. Someone say, okay, you never told anyone that was forbidden. Why do you strike me? So that's why we're publishing guidance. I think for the next month and perhaps 1 or 2 years, we'll keep doing that. And we'll then enforce. And we'll then ask, you've seen our guidance, you should know and you should implement. Perhaps one key point is the fact that be careful when you work with sensitive data, health data, minor data, biometrics, law enforcement data. This is something where you want extra lawyer to look at what you're doing because you do that. And if you do a general purpose AI, try to implement in your selection process of your data, training data. Try to also have, make sure you don't have credit card number in your training data sets. Do a bit of work in order to avoid being exposed to that, because we will probably be enforcing on those issues first, rather than general commercial AI.
Okay, great. The last one you mentioned was anti-discrimination laws, and I think this kind of brings us nicely into the sectorial aspect as well. So the idea that if you are developing an AI that's in a particular sector, you might be facing laws that are specific to this sector that you may have not thought about, that aren't even technical laws sometimes. Again, maybe starting with Suzanne, could you run us through what is the big state of thing around that? What are the key sectors, would you say, that are particularly regulated that developers should be thinking about?
So I guess here again, it always depends on what you're building, what's your product, what's your model. Of course, if you are in the aero industry, you're gonna get like used to being regulated, and you have like a lot of before even like being able to be a partner to yeah, you're gonna have a lot of regulation on that side. But medical products as well, if you're building robots that are here to help surgeons, of course, you're gonna, like, we're gonna have a particular regulation on this because, of course, it's like not just product safety, it's like product safety for like that are touching humans. So I think medical products, cars are also an industry that is already highly regulated, and where you're like autonomous car have been like a topic where there is a lot of discussion on regulation as well. And that also goes back to personal data, because a lot of the autonomous cars are actually like collecting a lot of personal data, which is also like something that goes back to the GDPR. The finance sector as well is very highly regulated. And I think I also wanted to mention that a provision in the Digital Services Act that is actually not, is related to the protection of personal data, but is not in the GDPR because it's in the DSA. It's a regulation on recommended systems. So basically, if you're training a model, if you're doing machine learning and you're trying to know better which are the advertising that are going to be the most impactful to the person, of course, here you have a provision, you have a few provisions actually in the DSA that are regulating recommended systems. So my point would be very like, it really depends on the sector and the product you're building, and actually then to try to ask yourself, okay, what kind of data I have, what kind of regulation that might already exist and apply to my business, and then pretty much, yeah, try to be as, you know, careful as possible.
Could you tell us a bit more as well on so again, the anti-discrimination laws or regulations that you mentioned initially? So when I said that this might apply to sector-focused things, it's because I imagine it might be particularly relevant in sectors. I'm thinking of HR, of finance, for example. Yeah, what is the state of things here as well? And am I right in saying that it's sector-focused, or is it actually everywhere as well?
So we were talking about that. So you have sectoral regulations such as aeronautics, automotive, medical device, and then you have regulation. For instance, regulation on HR is applying in every sector, but it's one function in every company. So it's somehow it's also sectoral regulation. Perhaps in the difference of copyright or GDPR applies to HR and a commercial use of database and different parts of the company. Perhaps it's a good example, HR, perhaps to move also to AI Act. HR software are not regulated right now, not really. You have anti-discrimination law to your HR processes, so you should not discriminate people when you're hiring people or when you're evaluating someone in your company. And there will be some AI system. There is already AI system that help HR services to filter the resumes they receive, for instance, or to pass tests. When you want to, you have different applicants and you want them, you will have a test and you have an automated analysis of the test. And this is where existing law exists, anti-discrimination. If you're able to prove that you've been discriminated by the company, you can act, but it's very difficult to prove. If you can challenge it on the GDPR way, saying, okay, you are processing my personal data to do that. I do not agree. So you have the question, okay, can we rely on consent when you're an applicant? Where obviously you will consent to anything the company will propose you because you want to apply to that company. It's very rare that you will say, no, I want to oppose that, and the company will say, okay, but so you don't come in. But the AI Act will provide some kind of additional protection some way and tools also for the regulator, because AI systems that are used for HR will need to comply with a few rules from the AI Act, and in that sense, it will really complement and perhaps operationalize for us, operationalize what we expect from this software in that context, and try and maybe make it more straightforward than deducing from GDPR all the rules that may apply to an HR software, for instance.
That's a very smooth transition into the AI Act, thank you, which we will talk about because it is an important topic at the moment. So speaking of the AI Act, my first question would be, who needs to worry about the AI Act? Is it all AI companies? Is it only companies working on things that are very risky? To what degree should you worry if you're building an AI today?
So first of all, I think I'm going to take a step back and just say that the AI Act is a regulation that is currently being negotiated at the EU level. We are at the final phase of the negotiations. It's called the trilogue. So the institutions at the EU level are actually making sure that they all agree on everything. And so it's still in progress. There are 3 things where there are still loads of discussions, but what you need to know is that the AI adopts really a risk-based approach. You have the risks that are unacceptable, and there you have three main topics where you have behavioral manipulation, you have social scoring, and you have real-time and remote biometric identification systems. And all 3 are considered unacceptable risk, and they're all forbidden. And then you have the high-risk systems with 8 categories. I'm not going to go through all of them. But basically, for these risks, we consider that you can still do them. But if you do them, you need to put in place compliance provisions, compliance strategies inside your company. And then we have the 3rd category, which is the lower level of risk, where you pretty much can do whatever you want without having loads of obligations. So I think this is very important to keep in mind, because here, basically, if you're not doing one of the 3 things I just mentioned, so social scoring or real-time biometric identification systems or manipulation of people, basically you might fall into the high-risk system, and then you have specific obligations. But to answer your question, basically you really here again need to look at the provisions in the law and see if you fall into them. It really depends on what you're building and what you're developing. And then if you don't fall into these categories, you're probably going to be in the acceptable risk section, where you can pretty much do not have obligations.
Would you agree, Bertrand, so that there's some kind of...
Yeah, exactly. So we wait for the final list of Annex 3 of the AI Act. We'll list the high-risk system. We mentioned some of those. I don't know, AI for the justice administration, AI for HR, some other biometric system. So you have a list that I think the co-legislator wanted to make it as specific as possible in order to make it clear for companies about who is concerned and not. But the list of the parliament is longer than the list of the council, so we will wait for the final risk. Maybe what I could mention is, for instance, one of the theme in the list is an AI system that is used to exam for students. Okay, it can be high risk if it's something that decide if you have your diploma or not. Okay, it's high risk. It could be high risk. What I would say is, we at the CNIL we issue guidance in September about the very same type of system and how you can comply with GDPR. So it still means that if you're not high risk, so you do not have additional provision from the AI Act, doesn't mean that you can do whatever you want regarding the AI Act. But if you process personal data and if it's sensitive or if it's with large effects on people, obviously you need to comply to GDPR funds.
Thanks. And this will be my last question before we open to the room. And my question is this. So I think the wider discussion around the AI Act for startups in the space is obviously that it's hard to prepare for something that we don't know when it's going to come or what exact form it's going to take. As a startup today, are there specific blocks that you can secure to make sure that you are future-proof in terms of regulation? I'm thinking of things like making sure you're transparent on X, Y, Z, or, I don't know, having a certain, having some kind of audits or logs or things like that. Are there very specific processes that you can put in place to make sure that you're ticking those boxes that are likely to be the ones that fall in upcoming legislations?
I think the first no is begin to document. Normally, it's a good professional practice to do that, but really document the data, document the source of data, what has been done, and be prepared to answer those questions and to answer the questions such as, do you have personal data in the training data sets, to have at least a clue? Do you have copyright data in your training data set? Also to be able to have enough documentation. Be cautious also when you use, a lot of AI systems are using existing data or API. So if you use ChatGPT API, if you use YOLO for computer vision, be aware of the limitation of that kind of either generic data sets or generic model, be critical if you want to use those bricks for sensitive use. If you want to do the YOLO to implement that on cameras for law enforcement to arrest people, you should be aware of being able to explain all the bricks that you've been used, and if you feel you don't have enough information on YOLO to do that, perhaps use a different data set or a different model, or even perhaps try to collect your own data for your model.
Maybe here again, trying to take a step back, and I'm going to say something that is not echoing what we heard this morning from Eric Schmidt. So I think, having looked at regulation on technology law for quite a long time now, I can safely say if we regulate it in Europe, it's much more efficient, it's much more valuable, and it's much more easy to apply. Before in the 90s, we had like directive where member states could pretty much then apply the laws in national with like their own interpretation, and we didn't have like a strong framework for people to actually just, apply across all EU member states the same law. And we should be thankful that we have laws at the EU member states. Otherwise, you would have to deal with 27 different national laws. And I also think it's another point. We're stronger together. We saw that with the GDPR. When we adopted in Europe the GDPR, we had an impact globally on that regulation. And what was the success story of the GDPR is that now pretty much all the principles in the GDPR are applied all over the world. So basically, the law we created in Europe is basically the standard that every company around the world is pretty much applying. So I think here it's a good success story. I think the AI Act is not as overreaching as the GDPR, so its impact will be different. But I'm a big fan of Europe, and I think EU regulation is actually a strong thing and much more effective for businesses.
Thanks both. Are there any questions? Yes, please.
Hi everyone. Hi Daphne. Nice to see you here. Well, thanks a lot for what you've just said. I think we should defend our institutions and avoid spitting on these institutions who provide the very much rule of law that the democracy is built upon. But probably why some of the external, the outside stakeholders, like startups, are afraid of the incoming regulation that they label as bureaucracy is because they perceive that the way in which the rules are going to be enforced and percolating through CNIL, for example, to and other regime could be seen as bureaucratic, intensive compliance. And my question to you, Bertrand, and in general, and we have Guillaume Avrin here, the national AI coordinators, what could we do to advance in practice a single point of contact for startups that deals with data, that deals with algorithms, that potentially, though it's not the same regime, deal with copyright, so that through guidance, like for example, could you start a working group, bring together LNE, who does measurements, CNIL, ARCOM and others, to discuss and to engage with the ecosystem that is gathered here in a way that can reassure them in terms of that these regulations that are coming will create a level playing field that will be eventually a source of competitive advantage. Is this something that we could hope? Is it something that is already there? And what should we do to anticipate as smart as possible? And it's already very smart. And I say that, Bertrand, because before your position, you were the National AI Coordinator. Yeah.
Well, so I think there is perhaps two elements to that. One is, once we have the AI Act, one of the effects of the AI Act on the regulator point of view will be to how we coordinate our efforts. Because the use of AI in the financial sector will be overseen by the financial regulator, the use of AI in the health sector will be overseen by the health regulator that already authorized medical device. Maybe the HR system will be a new regulator probably, or someone yet to define. And there will be, with many texts actually in the Europe, there will be a key question of how we coordinate the efforts of the regulators and how we make sure to companies that they will not have 3 different regulators asking for different rules, different evaluation scheme. I think we all agree that it's necessary, and it will, from my point of view, it will be launched in 2024 when we know which are the high risk, so which are our Dutch equivalent has a table of all the risk and all the regulators applying to all the risk, and they have this role of coordination, and so they are doing that, and perhaps there will be the single point of contact, or at least they will be able to orient companies to that regulator or that other. What I also see is that you have startups from, let's say, general commerce, that not used to regulation, but you have startups that are used to regulation as well. And we computer vision startups that want to sell AI to law enforcement. Okay, you have some that say, okay, I don't want regulation, but most of them, they know that it's sensitive. They know that they need to understand the law, and they know that there is a specific legal framework, and they invest in that. It's the same for health. So and I do not believe in a system where, we can disrupt everything and respect no regulation in no field, and it will be for the best. Obviously, some of these regulations are there for good reason, and you need to, obviously, if you want to go to a risky business that is high risk, you need to know what kind of legal landscape applies. And apart from AI Act, actually, that will give you additional things.
Yes, just down there. There were a few in the back as well. Okay. Cool.
Thank you so much for the talk, Suzanne and Bertrand. Maybe a question for you, Bertrand, and recognizing my French is limited, and I listened to President Macron's speech this morning without English subtitles. I heard that he said, the French government is kind of working on an AI legislation and regulation in 2024, the first half of 2024. Maybe I misunderstood it, but my question for you is, given the hurdles, that we're seeing with the EU AI Act right now, that there's possibility that it might not get finalized this year. There's a lot of debate on foundation model rules and all these hurdles. Do you think that France and other countries will kind of start drafting its own AI legislation, because the AI Act might not be implemented until 2026, 2027?
So I don't think he said that. Guillaume, I think he wanted to say that there will be global initiatives with OECD about how we can regulate, but more in a co-regulation approach, foundation model. I think this is what he wants to push in 2024. But that doesn't mean maybe people will try to replicate AI Act earlier before its entry into force. But I don't think. I think everybody wants to work on that. Maybe I will give one example. One example is the Olympic Games law that have been adopted this year. It's actually already, I've introduced elements from the AI Act, on computer vision system for security and law enforcement. So you have provision regarding the representativity of data, the detection and correction of bias, and detection of correction of errors. And so for us, typically, it is good a test bed for what will be expected from AI Act, and okay, what does that mean? How we can work with companies about documenting that, labeling data to meet that. So you may have a few laws, perhaps on health, perhaps on finance, that will be inspired by AI Act. It's probable.
A few days ago, there was this news, might be true or not, but the French police uses a software that allows to do facial recognition. We will see if they use it or not. How do you see regulation in, government states? Because you talked a lot about companies and private companies and startups and so on, but how do you see this kind of regulation happening within governments, and how do you control that?
So it's maybe different in different countries, including in Europe, because there are directives and not regulation regarding law enforcement. In France, they need to consult the CNIL, and in many cases they need a law. The example of the Olympic Games is that they need a law, and what has been reported in the press is typically something that is illegal because there is no law allowing them to do that. So the main checks and balances will be the parliament. And the CNIL in some aspect, because we have investigation powers on what the government is doing.
Maybe a follow-up question on the first question for Suzanne on the idea that in the AI Act there is an AI office, and there has been negotiation around the role of the AI office, and what I understand it's kind of settled 2 weeks ago. So there is also this possibility to have enforcement and investigation at the EU level. What is your take on this aspect of the law?
So enforcement is always a tricky question, especially when we're dealing with 27 member states, and we're actually discussing about this just before. I think one of the key issue is having one law is a very good thing. Having 27 people making sure that law is well understood, well applied is another thing. And I think national authorities are very much important, because they're really you cannot, as a startup, go to DG Connect and say, "Oh, I'm sorry, I didn't quite understand this piece of article. Can you please help me?" So pretty much what the national authorities are doing already, trying to help companies and startups better understand potential applications for their businesses is very crucial, and we need more money on this to avoid having enforcement problems then. And then we have the enforcement issues when we're dealing with application of the law at the national level, with the EU level, and I think we saw like a lot of problems with the GDPR enforcement, with the Irish Data Protection Commission being a bit the bottleneck of Europe's enforcement. So I think the new upcoming regulations, including the DSA, the AI Act, are trying to overcome these issues, and I think cooperation, like a good national or a few good national authorities working and helping compliance is very essential. And then having a coordinated enforcement system at the EU level is also important, but also still having some national powers to national authorities is like a key balance, I would say.
Do we have time for a last question? No? Okay, never mind. Thanks, everyone. Please join me in a round of applause for our fantastic panelists.
Thank you.
Thank you.
Thank you all for this great panel. We'll be back at 2:50 sharp for the next session. Thank you so very much for your time and your insights today. The next session, 2:50, will be with Jason Warner and Eiso Kant from Poolside. I'm very excited to welcome them. Good afternoon. Welcome everyone in the central room. We are excited to welcome you for the second session of the day. We are going to welcome Jason Warner, the co-founder and CEO of Poolside, and Eiso Kant, the co-founder and CTO of Poolside. They're going to discuss the future of software and the future of AI with us. Please give a big round of applause to Jason and Eiso.
Hey everybody. Good afternoon. How you doing? Packed room. We want to leave some time for questions. I'm hoping that's okay. We have mics we can pass around later. But we want to talk a little bit about what we're building at Poolside. So I'm Jason. This is my co-founder, Eiso. And we are here to talk about all things AI, but what we think that future looks like. And let's just start with a real simple tagline. What are we doing? We're building the world's most capable AI for software, and we think that that is going to unlock what AI is actually capable of. More than anything else, we think that this pathway, through the specific software capability and focusing on this, is a world-class way to think about what is available to us as humans in a way that's never been available to us before. And I think we want to talk about, technically speaking, all the different ways in which we're going to achieve this. But why don't we talk about a little bit of the positivity first, Eiso? A view on this that you want to take.
Yeah, so so for us, we're going to spend a bit of time today diving deep into what's Poolside. For those of you who've heard of us, you probably are used to a website that has just contact us, and we've been quite in stealth mode, and we thought it'd be a good day today to share a little bit more. But before we dive into Poolside specifically, it's a bit about our view on the future. The way that we look at the reasons of working towards progress in artificial intelligence and in increased capabilities is really coming from a world that we all want to live in, a world that has a lot more abundance, the ability to actually apply these capabilities and these models in healthcare, in science, in housing, in education, in all of the areas that are actually going to impact our lives. But to be able to get there, we're taking a different path than some of the general purpose approaches that you might have seen in models like GPT-4 from OpenAI. And as Jason described, really focusing on a single capability, the capability of software development. And the capability of software development for us is actually an incredible proxy task for human intelligence. If we think about kind of the pillars that sustain what it means to be able to be skilled at human level tasks, we have the need of having an understanding, a model of the world. We have the need of reasoning, and we have the need for planning. And if we think about software development, what we're doing is when we're going from an idea to running software, we need to have all three of those capabilities to actually do so. And this has kind of been the starting point for us on our journey. It's actually how Jason and I met, quite a few years ago. Maybe you want to tell part of the story?
Well, sure. That was a little diversion, but here's the story. It's actually quite simple. So I'm the head of engineering and infrastructure at Heroku. I decided to join GitHub as the CTO. One takes GitHub from a code host, social coding, and turn it into an end-to-end software development platform. We're about to kick off two projects. One that would become GitHub Actions, that is off and running, and the other one that would become what is known today as GitHub Copilot. And in that endeavor, trying to get GitHub Copilot kicked off, I ran across this tiny little software company called Sourced, and that was Eiso. Eiso was exploring AI on source code before almost anyone in the world was. I think there was only one other company in the world at the time doing this. So I tried to make an acquisition offer. I did make an acquisition offer to get Eiso's company into GitHub, and it didn't work out. But instead, we started a podcast. I don't know how you go from trying to acquire a company to starting a podcast, but that's what we did. And instead, here we are 6 years later doing this now.
And that led us really to this moment of becoming friends, and at the beginning of this year, frankly, having what we call an OpenAI-induced existential crisis, which I'm sure quite a few people in this room might have had. And for us, it led us to this viewpoint: if we believe in a positive future, we believe in a future where technology and AI progress is going to impact every single thing that we do in our lives. If you believe in a future where neural networks are capable of learning anything and everything that we're capable of as humans, then you find yourself with the question of what do I do next, right? If you believe that happens on your lifetime, that really comes to that point. Yeah.
So let's talk about it specifically then too. So okay, so what sets us apart from OpenAI and Anthropic is that we're focusing on a singular capabilities, the singular capability being software. And it's important that we distinguish between code and software in what we're about to say next, because code is one avenue and one underpinning of software, but software is a very large category. But it is fundamentally the focus on software that is going to set us apart. So what decisions are we making that are different than their decisions, and how is this going to impact us, but how is it going to manifest for everyone in the room here?
So let's maybe start with what we expect the world to look like from what we're building in the next 2 to 3 years and into next 3 to 5 years, and then dive into a little bit some of the decisions that we're making on the technical side and on the strategy side to get there. So the view we have is that in the next 24 months, likely every software engineer in the world is using an AI pair programming assistant. And this domino already started falling several years ago when you did GitHub Copilot. But we're still in a world today where these assistants that we have are useful, quite often wrong, and are still far from actually truly being a pair programmer. Right now, they can give us useful recommendations, they can give us ideas, they can at times give us code that works, and at times give us code that might be directionally correct, but doesn't work at all. But that world is going to continue to change as the capabilities of these models, and this is what we work towards, increase and improve, to actually get to the point where we're truly, as engineers, pair programming with a system that is becoming as capable as us, and someday more capable than us. And this brings us kind of to our view on the world over the next 3 to 5 years. We think within the next 3 to 5 years, the vast majority of software that is going to be created in the world is going to be created by people who don't have any software engineering background whatsoever. Maybe not even a knowledge about code or about architecture, about cloud services. Because what we see is that the world is very likely to move to a place where we'll start having capable enough models that can go from a high-level instruction task, help me build accounting software, help me, understand something in this genomics data, to an actually AI-led, human-assisted conversation that leads to fully running software. So the picture that we like to paint, where we believe the world is going to be in 5 years, and you can hold us accountable to it, is that you are going to be talking to a system, describing high-level first what it is that you want. One of the main things that we all know about software development is that it's not as easy as saying, I want an app that does X. Right? In reality, what's necessary is afterwards a very lengthy back and forth conversation to understand what it is that that application actually does, what it is that the person actually intends to do it, and then how to bring it out into the world. What should it look like? Software development always has been about constantly iterating on ideas to get something to an end user. And for us, this is what we want to enable and just make significantly faster and make available to every single person. But to your point, yeah.
I was going to say, actually, so let's dive into this a little bit too. But why? Why focus on software? Do you think it gets us to an end goal faster?
So the focus of software for us is a little bit of a head fake. If you look at today where large language models are at, they've started building a pretty good model of the world. Right? Language models are starting to understand that if I put my phone on top of an apple, it's going to fall off. They're starting to have a reasonable understanding of good amount of knowledge. But when it comes to reasoning and planning, they're still in the early days. We are at a point right now with models like GPT-4 that we can see useful reasoning, but on more complex tasks, it pretty quickly falling apart. When it comes to like complex planning, giving a high-level objective to a model and actually getting to a whole set of final tasks, we're still very far from it. Now, the reason that we're particularly excited about the path of software development is because of something that's quite unique, source code. One of the only things that neural networks can generate that we don't need human feedback on, but that we can actually run, introspect, and execute is code, which means that we have an actual oracle of truth. We have the ability to take something that a neural network generates based on an instruction, a set of code, and actually run it and see what happens. Does it compile? Does it work? Does it throw a whole bunch of errors? Does it pass certain tests? Does it actually, lead to the outcomes that we're looking for? Right? Code is a formal form of reasoning, and it's a formal system in which we can actually introspect and understand what's happening. And that's really the insight on which Poolside is built. And we can go maybe a little more into technical details. Or
well, I think it's worth us going into a couple of the strong beliefs that we have on this front. So we can go down the path of when we talk about self-play, when we talk about synthetic data, and when we talk about reinforcement learning.
Yeah. So to paint a bit of a picture of the world right now, if you look at GPT-4 and some of the models that are out there, you'll often hear about reinforcement learning from human feedback, right? The ability to use fine-tune a model based on the preference data of people, which answers they preferred. If you follow the school of thought of what Anthropic has been building, you'll hear about reinforcement learning from AI feedback or constitutional AI, using another trained model to be able to actually give feedback on what the preferred answers are, to have a model learn and actually increase its capabilities. Poolside is entirely built around a technique that we call reinforcement learning from code execution feedback. So very practical, what does that mean? We're not just training end-to-end a foundation model that is entirely targeted towards software development, but we're taking that foundation model and we're letting it actually act in over 10,000 real-world code bases. So what we've done is that we're building this massive sandbox environment with 10,000 code bases that we've taken from public sources like GitHub and such. And we've made executable, similar to how a developer might load it up in their editor, and actually run things. And what we've done with that is we've identified the millions of tasks that developers have done in these repositories that led to code being outputted, that then for which they actually wrote test coverage. And what this means is that we have an oracle of truth. We have data that didn't exist in our training data, that our model has never seen. We have millions of tasks defined that are real-world software development tasks that actually represent software development as how we do it as engineers. And we can ask the model to take attempts at solving those. Now, when you do this in the first attempt and you just ask them to solve it, you'll realize that models today fail on the vast majority of software development tasks still. But they are getting better, and they're getting more useful. Now, our approach to consistently improve these models, outside of training better base models, is to actually use that interaction between the model itself and the oracle of truth, the code execution environment, to improve it. Now, we do this through a bunch of different methods. One is actually through letting the model go and attempt lots of different versions. We apply planning algorithms to be able to understand the different versions that our model is able to generate to try to tackle a problem and try to discover in that big search space what is actually correct. What this ends up leading to, though, is that it ends up leading us to novel solutions to the original tasks that actually match the tests and the constraints that the original developer wrote. Now, to very kind of plainly say this for anyone who isn't on the technical background, when you have a large language model that you're training, you're teaching it about code by showing it lots of code. But when you're taking that large language model and you're giving it real-world tasks and environments where it's learning when it's correct and when it's wrong, and when it's exploring different options that could work and don't work, you're really starting to teach it how to code. And that particularly has impact on problems like the hallucination problem, improvements in reasoning, and we believe over time improvements in planning.
So this is one of the key differences between our approaches. With the focus on software, we're going all in on all the things that make software development easier, better, more enjoyable for folks, but also the more constrained in some ways, and that it's the domain itself is going to allow us liberties. And I think it's important to keep reiterating this point, but it's even more important to keep focus on the idea here that with the oracle of truth, as you've been saying, with the source code, we have the ability to keep testing these things out. As we grow, as we bring it to customers, as you all start testing these things out and using your own code bases against it, it will evolve over time. And I think, do you want to talk about a little bit about the going a little bit further on the oracle, the self-play, or do you think we should?
So I think there's one part that breaks a lot of mental models that I often see, that we've even had in the past, which is this notion of synthetic data, right? Our view is that in the next 3 to 5 years, every piece of data that any large language model or equivalent models will be trained on is going to be entirely synthetic, meaning that it was actually generated from another model. And this gets you into this oxymoron of how can an AI model learn from data that was created by its own model. And we think this happens first in code and software. And it's really to what I described earlier. When I give a problem to a large language model that on first attempt it's not able to solve, but by exploring that search space with planning algorithms, it is starting to able to get to a real solution that wasn't in that original training data. You've just built a definition of synthetic data, right? You have data that didn't exist before that was created by a model. Now we see this actually very visually in images. For anyone here who's played with DALL-E 3 or with Midjourney, you can no longer argue that the output of these models, right, is not in the training data. And so we're starting to enter into this, what feels like kind of a weird world, that we can actually improve models and continuously train them where the source data was no longer actually generated by humans. Now this requires massive skill and multiple years to get to the point where it's all entirely synthetic. But already today we see a path that on code, which happens before language, because it's a lot easier to validate if the data that's generated is correct. But it's a lot harder to validate if a synthetic article written by an AI is going to be agreed on to be in training data, and requires a lot more humans versus actually compute. And so this is kind of our view on synthetic data and self-play. Yeah.
So now let's go back to a point we made at the top. We've just talked a little bit about our approach. There's a couple of things we haven't talked about in terms of the data going into the model yet, but we'll save that for another day. But we also said we're focusing specifically on software because one, it's a focused capability, but two, we thought it was a faster pathway to reasoning and whatnot. Now let's play that back again with what we just talked about here and why we hold that view if we played this through.
So we look at the ability to write code and create software as a proxy task for reasoning and planning. When we go from a high-level objective, I'm sure plenty of engineers in the room, and someone says, hey, I want you to create software that does X. That's a high-level objective, and by the time you're done with it, you've gone through a massive planning task, and you've done a lot of reasoning, you've done a lot of work. So for us, being able to right now start getting large language models in a place where they're able to go from an instruction to working novel code, you can no longer argue that reasoning has had to happen to get there, right? And so for us, the further you push the capabilities for an AI to create software, the further you're pushing the capabilities of reasoning. Because the vast majority of code is just that. It's just a language that we've created to do structured reasoning, to deal with data, to deal with effects on environments. And so for us, it's a perfect bubble in which we can test things, but it's not an academic bubble. I would love to work on formal math, verification in AI, but it'll probably be not that useful to most people, in this room. But if we can push forward the capabilities of code and software, it's useful to almost every single person in this building and in this world. Because the thing that got us really excited and what has us just so insanely optimistic about the future is what we've seen as engineers. How many people here are software engineers or write code? Go in the room. So quite a few of you. So everyone who raised their hand, here's a superpower. You walk around, you see problems in the real world. That can be when you're in a factory seeing a CNC machine. It can be when you're standing next to a scientist who's trying to do some data analysis. And you know that if you had infinite time, you could solve their problem. And so for us, we just want to expand that superpower today for developers and one day for everyone to be able to have that. And we think that leads to a lot of innovation in all of the areas that actually matter, right? Healthcare, education, housing, all the things that really touch our lives.
So let's talk about what we see is going to happen in the next couple of years from the future perspective and how we've broken down internal to Poolside what we think our milestones are going to be. So stage one, and I'm going to ask you to give an example in each one of these stages. Stage one, which we're in at the moment, we think is basically assisting developers with the most capable AI system. So what does that look like today?
So assisting developers today looks like on the right side of your editor, aware of your total, your code base, context aware of all the knowledge that sits inside your organization or the project that you're working on. There's an AI that can start helping you do the things that you actually would prefer not to do. But most people who aren't software engineers don't realize is that actually writing code is not the job of software engineering. Right? The job of software engineering is thinking of solutions that can solve problems and making them often work at scale or making them work faster and bringing them to an end user. And so what we're really looking at is AI assistance that starts with in the editor, but at the same time is also a platform of the most capable AI model for code and software that anyone else can build applications on top of and unlock a lot of interesting things. And this is, I think, what we're going to see over the next 12 months spread out across our entire industry.
Right. So essentially co-pilots
Yep.
everywhere. Co-pilots everywhere. Step 2, we're going to allow anyone to build software, but this time AI-led and human-assisted. So we're flipping it from human-led AI-assisted to AI-led human-assisted. But practically speaking, what might that look like?
I think it's really this conversation. I think it's if you have an idea for software in your head, you are going to a system and you're going to say that awful phrase that all of us have heard as software engineers was like, can you build me an app that looks like Twitter that does X, Y, or Z, right? At this point, you realize that even if you wanted to go do that for that person, the next thing is not that you go and write code, is that you actually get a whole bunch of questions back. What do you want it to be for? What do you want it to look like? And that back and forward conversation is going to be AI-led. And it won't just be text, it will be visual as well. It'll be examples of running software. You'll start opening it up and you'll see, actually, no, I don't like the color scheme here, or it doesn't do exactly what I want. And you'll be building together with an AI. Except in this world, you're no longer in the driver's seat of writing the code. You're in the driver's seat of building the software, but the system is actually the one that's intelligent enough to have a model and understanding of the world. It's strong enough at reasoning, and it's strong enough at planning, and through it the capabilities of building software, that they can actually provide you a real end piece running software. So for some problems that will take a 5-minute conversation and you'll click on something and it'll work. And other complex things like full businesses and full software things might require multiple weeks or months of back and forth to get to something. But it's no longer going to be bandwidth limited by the number of engineers that can collaborate to write code to make it work.
Mostly GPUs at that point running. So then step 3, technically speaking, step 1, we should probably aim for profit, but step 3 for sure is going to have profit involved. But step 3, we've said internally, we want to generalize these capabilities, generalize the software specific capabilities to other fields. And what do we mean by that?
So I use the term head fake a lot, right? And I heard it on an incredible talk by a Carnegie Mellon professor many years ago called The Last Lecture. If anyone watched it, it's fantastic. Because for us, focusing on software development is to some extent a head fake. Because once you are able to go from an idea to running software, you've created sufficiently advanced capabilities in understanding and reasoning and planning that you're very likely to be able to extrapolate that to almost any other task that we do. At the same time, though, software today, software in 5 years, and software 5 years ago are starting to look very different. There's a famous quote from Andrej Karpathy back in 2016 that he wrote on his blog that said, neural networks eat code. Software today is no longer just actually code being written, but it's also starting to use these models, right? So all of a sudden, we have where previously we would have written code, we have models, one or multiple open source ones, API calls, and we have the actual code. And models are eating more and more of software over time because they're able to do things that before you would require to write code for, but now the model is capable of doing. So when your model is capable of perfect reasoning, of planning, it understands the world, you no longer need to write code. The model itself doesn't need to write code anymore at all because you're able to start defining your applications and your software that you want as purely neural networks. Now this future is still a ways out, but we already have plenty of examples that show that. There's things that we do today with these models that before we would have written thousands of lines of code for, it wasn't capable at all, that now we'll just actually give it a prompt for and we get the output for it. So at some point, if you ask me, like in 30 or 50 years, or don't hold me to timelines on step 3, but into this further future, what's going to be left is weights. It's going to be left neural networks that are weights that are probably burned directly on the silicon that we're running. I know, however crazy that sounds, it's what we're already getting the early signs of. And so I think everybody here has to ask themselves the question of, are we on a trajectory where we think neural networks are going to be able to learn anything and everything that I am capable of? Now, we very much hold that view. And we very much hold that view not from the world is going to end AI apocalypse that you've heard a lot about in the news. We hold that view from if we can start building these systems, we can start getting a lot of abundance in the world. And that's really what I think is hopefully the positive message that we want to leave with a lot of this.
And if you take nothing else away from this, take the Andre Karpathy. That was one that influenced both of us the most, which is neural networks eat code. And the longer you spend in this space, the more you realize the truth behind that, but what's possible when that is true. We wanted to leave time for questions, but I think we actually ate up most of it, so we probably have time for a couple. Is that right?
One or two?
One or two? Yeah. Sure. You want to stand up and just yell?
Hi everyone, my name is Nico. I lead an AI governance organization called the Future Society. Well, congrats. It's great to hear your plans. It looks very exciting, but also a bit scary. So I guess you came to Paris for the talent, for the compute, and thanks for coming here to develop this amazing project. Can you tell us a little bit more about your plan to align this kind of powerful agents? Because how are you going to count on the Paris ecosystem, alignment ecosystem, to try and solve this complex, because you're you're pushing boundaries, as you're saying, towards planning and reasoning, which is something that Demis Hassabis has been looking at, for example, for years. So what's your plan on alignment?
So what do you mean by alignment?
Well, trying to align the way in which you push the boundaries of equipping these models and agents with reasoning and planning capabilities in a way that they are aligned and are controllable.
Right,
in that sense.
So I'm going to keep coming back and forth on this. So what does that mean to you? Like, what does what does it look like for something to be aligned to you?
That doesn't hallucinate, that is controllable in a way that serves the tasks that eventually the humans on the other side, as societies, as individuals, as companies, are willing to give them. So, as you said, it's really moving the next stage of having non-software, no code-based, language-based software advanced development. And so there are intentions there, bridging the gap between what are these original intentions and how this is created and controlling that in a way that is robust. Does that make a bit more sense?
It does, and I'll let you answer this question in a second, but I want to challenge in here one thing, which is whenever we get into the alignment discussion, we always assume that these things are runaway trains and we have no control over them. And there's no checks, there's no controls, and there's no, and it's a full automated system. And I think that that's not something that we should assume. We're building these systems. We can build the systems however we want. This is why I always say whenever someone talks about the existential terminator scenario, I'm just going to come back with 15 different questions. But the hallucination question, some of the agency questions, that's something we've already thought about, are we going to put in? And frankly, because I actually have a really bad saying, which is it's a how I want to sell software. You never try to give a spaceship to a caveman. Cavemen don't know what to do with a spaceship. But what you have to do is you can still introduce advanced technology to a different type of society, but you have to take everyone on a journey. Just as like when you're teaching your children how to drive a car, they have sat in a car for the past 16, 17 years, but they don't know what to do the moment they get behind the seat. You still have to walk them through each one of those things. It's taking them on a journey. So we have to take ourselves through the journey. We're talking about a future. We see this future. We're going to build towards this future, but it's going to happen over multiple years. Let's call it a decade. So we're going to take a journey together, and we're going to introduce gates. We're going to introduce checks. While we could automate something today, it's still going to be a check on one side before we get to that point. And at some point, yeah, that step gets automated. The next one is the check. Then the next one is the check. It's kind of the same way we've always done this in the industry. We're never going to jump from here to Terminator. We have to work our way through all those. But you have a specific couple views on this.
So it's really easy when you're founder in this space to find yourself in a lot of debates and discussions around alignment and safety. And I think it's important that the topic is on the table. But I think it's also important to stay where we are today. And it won't make us most popular with everyone. Today we are with auto-regressive large language models that in no way in their architecture and where we're at have any sign or any indication of becoming a runaway train. And it's very easy to make that conclusion of like, hey, as we increase capabilities in models, we will lose control. And this is actually something where I think we need to, as Jason said, as we increase capabilities in models, we need to truly understand what the impact of control of the systems and models is. But I don't think it is fair to use, and by the way, this is not what you were doing, but I'm taking the broader question in the industry. I don't think it is fair today to assume that increasing capabilities automatically means loss of control over these systems. This is not how they're being built. This is not how they're actually focused on alignment. Now, to very specific questions of hallucination, there's a lot of work that can be done there. I think there's a couple of areas that are incredibly important. One is interpretability work of these models, right? The ability to understand when we feed it data and something else comes out on the other end, what actually happened. Because there is, there's a complex approximation that happens inside these models that we are not able to fully introspect there yet. There's really nice work happening in the space already, but we're still very early and we should be investing in that work.
Thank you so very much, Eiso. Thank you so very much, Jason. We have a packed agenda, so we'll have to stop for now on this session. I would like you to give a big round of applause to our speakers. Thank you so very much. At 3:25, we'll have a great panel. 5 panelists are coming to talk about AI for organizations at 3:25. That's in 3 minutes. Good afternoon. Hi, everyone. Welcome to the Central Room. Super happy to welcome you for the next session. We're going to have a huge panel you'll see on AI for organizations. So the panelists are Charles Gorintin, the co-founder of Alan. We'll have Renaud Allioux, the co-founder and chief innovation officer at Preligens. Rata Jacquemart, co-founder, CEO of Differs. And Jean-Baptiste Hironde, founder and CEO of MWM. This huge panel, as I said, will be moderated by Benoît Berthelot from Bloomberg. Let's explore plenty of topics, right? Data sensitivity, market dynamics, and all your business efforts. Please welcome to the stage Charles, Renaud, Rata, Jean-Baptiste, and Benoît.
Hi everyone, thanks for joining us. We are lucky to have 4 guests here with us to discuss really the AI revolution inside their companies. They are all companies using AI for their products, but also they had to learn how to use AI internally, and we're going to discuss what it changed for their employees, the way the company is organized, which employees are working with AI, what is the AI team, what should it look like in their companies, etc., etc. So just a quick introduction again. We have over there Charles from Alan. Everybody knows Alan. You're also an advisor for Mistral, who everybody heard about as well. Rata Jacquemart, just here, you are the CEO of Differs, a startup that's helping retailers to find the right sale price for each product with the help of AI. Renaud Allioux, here with the white shirt, you are the co-founder of Preligens, which is a defense tech company used by the French Army and NATO, using satellite images, also geospatial data for intelligence. And Jean-Baptiste Hironde, you are the co-founder of MWM, a publisher producing and developing creative consumer apps for music, drawing, photo, and video. So my first question would be, it's been roughly a year of us living with generative AI. Obviously, the revolution that's making a lot of buzz and this push in the AI field. And I just want to know what it changed in your companies, if at all, for your employees and just for your company, its life in general.
Hi everyone. So it changed a lot of things for Alan and especially for me. So basically at the beginning of 2022, I was like, there's something brewing in the generative AI space. I'm gonna give up everything that I'm doing as a CTO and I'm gonna focus solely on AI. I had studied like 10 years ago, like in the AI. I was doing a little bit of AI, but like that was ages before like the generative AI technology. So what I had to do was to get back immediately into learning and getting to know intimately like how that technology worked. And then it was all about sharing with the organization. So what it changed at Alan, we created a plan where first we wanted to educate everybody in the company on how to use that technology. You've all heard someone say, "Oh yeah, I used my cousin used ChatGPT once, and it basically hallucinated a bio for him, so I'm never going to try it again." And basically, that's exactly what we wanted to avoid. We wanted to educate everyone in the company to make sure that people knew and tried the thing, so that they wouldn't be scared about it and they wouldn't just discard it as just another wave of fashion in tech. And once we had done that, we've seen amazing stuff in the company. So basically, in order to educate, we had created some workshops. We had created a generative AI academy inside the company. And once people went through those things, we started to see innovation come up everywhere in the company, like from the most junior intern was able to create stuff that we had never seen before. So we were able to increase the productivity, to reduce our costs as a company, and to increase the personalization of our product. So it really changed a lot of things for us.
Rata, you want to?
For us, it's the same. Like if in your company, not everyone is using generative AI, I think that's strange. So for both tech team and business team, we use it, I don't know, yeah, every 10 minutes at least. But so on the tech team, of course, it's Copilot. You spend much less time to code now, like instead of looking on the website, which library that can help you and stuff. It's the speed goes up by 2 at least. And on the business side as well, it helps us a lot on content creation, on a message creation. We trained, with the right prompt, we can train generative AI to understand. Well, we use ChatGPT for now, but we can train super easily ChatGPT in our case to understand our tone of voice. So we have like Rata's tone of voice, we have different tone of voice, each person tone of voice, and yeah, it's crazy 2 or 3 times. And really, if you haven't started yet, yeah. But however, it doesn't change at all on our market. Because, well, we target retailers, especially mid-market retailers who don't have data science in-house. And what we observe is that, well, now today with the economic downturns, retailers, they are suffering with their consumers who have much less purchase power than before. So what they're looking is more predictive AI, actually. What we're doing is more like help us predict the consumer's behavior so that we react, so that we take a right decision. We don't see any customers we are talking to that need like generative AI use case to have, I don't know, models that change colors of clothes. Well, we don't see that yet. And so it doesn't change our market at all, but it can be interesting to add like a feature in our solution, but not on the use case we're targeting at all. Yeah.
Renaud, same question for you.
Yeah, so I think it changed 3 things. First, I would say we did not discover generative AI this like 1 year ago. We used it a little bit like with GAN and style transfer and this kind of thing because we are focusing on processing images, so more than images and text. We are not really AI in text. So, but this gap we saw last year is really unprecedented. And so we had a little bit of work in generative AI, but not at this scale. So the first thing that changed is, I think, as you said, we starting deploying it a lot in the company, maybe a little bit more carefully than other company because as a sovereign defense, etc. company, we have to be very careful with data privacy, IP, etc. But of course, we want like everyone in the company to use this kind of tool to to do better job. Secondly, it changed also how our client perceive AI and perceive our product. So we are providing basically image analysis product for video, for image, for satellite images, etc. But they are starting to ask, okay, is it possible to interact it with as a chat? Like, is it possible? Could something which would be interesting? Is it something that we should develop? So we started to emerge this kind of question from client, from someone. All our clients are very operational guys, like some are analysts, some are special forces. These are not tech guys, but they heard about it and started to ask questions. So it started to maybe how it's in product started a little bit to change. And at the end, you see, I don't think most people know about Preligens because of our company. We don't make lots of fuss because of defense and stuff. But I used to be CTO until last year, until a couple of until June. And actually, a reason why I decided to be chief innovation is because of generative AI. Because in defense, operation is very hard. So we have 150 engineers. We have to deploy product in classified environment, go abroad with a USB key, and this is very painful. And we discover, okay, if we want to be up to the task, to everything what's going on in AI, we need to separate a little bit innovation from operation. And as a CTO founder, I say, okay, I want to change from operation to innovation and take this 5-10 people, a little bit as you described, and say, okay, how we can think about internal use of generative AI, embedded AI, what is the future of our technology, and actually I think there will be a press release that we will, for example, start developing our own foundation model for defense and geospatial application, and this is directly in fact consequences of that. So I think it changed a lot, for everyone.
Renaud, same question.
Just to add something new to this dialogue, we have been developing and working on AI for now more than 4 years and a half. So I can't say it's something new. It hasn't changed drastically what we are doing every day. But for me, the biggest impact I see in my company is about the impact on the product. So the time to create the product, the time to go on the market, and our engineers are continuing to work on AI, and they started this in the past 5-10 years ago. But everything goes faster. As we said, time flies, and the idea is that as a CPO in my company and a CEO, I can see that we have to change every process and methodology in the product process conception and development, and we have to run in this very, very aggressive worldwide battle around creating the best product with the best technology to address new market or your market, your actual market. So just to add something, it's more about a very deep and real impact about the product, the quality of what you can offer to your users. As inside, that's for me the big change and the new paradigm to understand.
Yeah, because obviously AI is offering big business opportunities, new business opportunities, new markets, new products for your companies, new customers to reach. And I wonder how inside your companies you organize this dialogue between the tech teams and the business team on the AI topic, because your tech teams have the most insights on the technology, what it allows. Your business teams probably have ideas. They don't know as much about the technology. How do you do that at Alan, for example?
So I think you'd be surprised because, in fact, it's the tech teams that are the most conservative about AI.
Totally agree. Yeah, it's the same for us. Yes, it's the last team that used generative AI.
Exactly.
What do you mean?
They know how it works.
So they have the head so much in the code. They didn't have time much to do yeah, the word, yes, the observation of what happened.
And so basically, like the latest generation of generative AI basically allowed people who just had to type a little bit of words in a box of text, and they could do something. Like that was not true in the previous generations, where you had to have a whole team of data scientists, engineers to actually create something. Now you can prototype with just one person who doesn't know much about tech. And that's a huge change. And so basically, there's no like tech team and product team that thinks of things. Now it's just like anybody can prototype an idea, and then we can take it to life. It still takes some energy, but you don't have to be. You don't have the gatekeeping of the technology team to say, is that possible to try?
So that would be the business teams challenging the tech team to find a solution. Can you give us examples of?
Yeah, for example, like I was mentioning, like an intern in our company just created tools to, for example, translate all the presentations that we have for our sales team. And like just with one button, we can translate all the presentation. And like no engineer would have come and said, okay, I'm going to try to build that if nobody had told them. And like just that person, a super junior intern, like was able to do it by himself and create a lot of value for the company.
Renaud, how is it at Preligens?
Yeah, so I think at Preligens it doesn't change much the process, but more the topic. So we have been selling AI application for 8 years, and it's always has been challenging because you have to manage the hype, I can say, especially with users who, you know, they don't really care about AI. They care about how to actually win a war when there is a war, protect the country, this kind of thing. So you have to show them how it will be useful for them from the beginning. Otherwise, they don't really care about the tech. And what is challenging is there always have been this great expectation about AI. I remember the first interaction we had was like, okay, can I have like some kind of app on my smartphone? I just push a button and I find the bad guy, and I have 30K. And we're like, no, but we can develop you something to detect car on satellite imageries. It would take 2 years of R&D and $2 million. You know, so this kind of expectation match is complex, and we always had to do that. And it's structured like any, I think, innovative companies who selling disruptive tech is to have very good product manager, very good team to manage to bridge the gap between expectation, hype, operational use case, and make the tech deliver the result. It's hard. It's always hard. Has been hard for 8 years. It's still hard now, and I think will always be hard.
Renaud, you develop apps, new apps. Sorry, Baptiste. You develop new apps that are in fact business ideas. They come from the product teams of the company, and the tech team has to help develop these apps, or how does it work?
Yes, the big advantage and the good news for a product team is that they are able to test themselves their ideas. So I have an idea. I can try and I can go on the web I can start big servers on Think Diffusions and run on big GPU, very big model, open source model that I've just downloaded on Hugging Face in few hours or minutes, and I can test if my idea is good or not. I can see the results, and after that I can go and talk to my R&D team and say, okay, I have this idea, this is the result, I have made a lot of tests, it works, can you put this online? And in the past you have to, okay, I have an idea, I'm a product manager, I'm going to pitch my idea to my CPO or to my manager, and then the guy is going to pitch the CTO, the R&D team. Okay, we can do that, but maybe it will take 1 year, 2 years, 3 years of development because based on our track record, when we want to launch something, it costs X, and it's around 6 months, 10 months, or plus. And what I ask to nowadays in my company, what I'm expecting from my product managers is to be very autonomous in the realization of the MVP. So they are able to create their own MVP just with APIs, open source system, and they can test everything before asking the tech team or the R&D team, because it's a fight of time, so the time to market is very important. And if you are able to reduce the gap between delivery and ideas, maybe you will win on the market, especially in the mobile market, because we have millions of apps and 100,000 of competitors. So it's very specific because it's B2C market worldwide with a lot of competitors.
The thing that we've been noticing is that there's a collapse of the talent stack. So basically, where you needed to have a full team of like 8 people to actually produce a product, now you can do it with 1 or 2 people. And that removes a lot of overhead in terms of in terms of communication, in terms of decision making. I'm sure you're gonna see in a lot of companies, a lot of places where like just 2 people are gonna be able to make like enormous businesses or enormous products inside the companies, and then there will be a lot of teams that are gonna pivot into supporting those 2 people instead of being like part of the core team of the product.
At differs, how do you manage this tension between the product and the innovation? What is driving the other?
You mean the tension between the tech and the business team?
Yes, exactly.
Well, we don't have much tension. Actually, our first principle is that the tech and the business team are equal. And I faced this chance to have this structure when I was at BCG actually. So at BCG, they are BCGX to data science, and we have BCG generalist. And it was the first place in the world I saw that we were really treated equally. Like it's in the culture. Finally, is a respect, because in some companies I see that it's a business who decide and then the tech build it without being much heard. We say in some companies, in Silicon Valley, for example, there are a lot of mainly tech first that telling business to follow, and yeah, what I saw at BCG is that with the equal respect system, it works so well, and is what we postulate as a first postulate first. So yeah, everyone listen to each other, respect, and yeah, so not on our side, no.
So on equal foot, and there is a good dialogue.
Yeah, it's in the culture, I would say. Yeah.
Okay. In this era of ChatGPT becoming ChatGPT-4, ChatGPT-4 Turbo, etc., this acceleration in the innovation in the AI field, it feels it's constantly accelerating, and your solution is so quickly outdated. How do you manage that inside your company? Do you just say we're going to take the best of the shelf AI application and just use it, or do you keep on wanting to develop your own AI solutions, even if your capacities are not the capacities that can equal the best player at a given moment? How do you manage that?
I think it really depends on the use case, on how much money you expect to make off of the feature. Is it core to your company to really go deeper? I usually try to write a weight equation where basically I try to compute how much money would I save if I didn't put a team on a topic, try to develop the next thing. And just wait for the tide of the innovation to come back and get us. And so that allows me to evaluate like how much efficiency should I miss and how much would it cost to actually develop it, and is it core to my business that I actually learn more and get better at that specific thing. So for example, for Alan, we receive hundreds of thousands of invoices a year, and basically it costs us a few millions to actually pass like manually. And we had the choice of like either trying to develop some models based on open source and try to really automate our stuff, or wait for a GPT-4 vision that could pass automatically the images. And we decided to actually make the bet of training our own models on document processing, because it was so core to our business. Because if you can pass things very efficiently, you can reimburse people in less than 1 minute. And so that's what we decided to do. But on other stuff, we're just going to wait until it gets better, and we're going to reap the benefits at the end.
Renaud, on this.
Sorry. Yes, I think the first thing is for computer vision, it's a little bit less mature than language. So we actually tested it, all the foundation models. There is generic foundation model, and it actually doesn't scale to specific application yet. But what we do usually is we have this kind of infrastructure and code infrastructure we call the AI factory, which is in fact a modular code base, where the research team, part of their mission is to test this new innovation and find, okay, this thing seems interesting. I'm going to put it in the AI factory, but put it like a modular, parametrable way. So, okay, I will put this new neural network, but you can change actually a little bit the architecture, you can change the backbone, you can change the different parameter, and you hardcode that in the infrastructure. And so everyone can test it and use it. And so every year of our 50, 60 data scientists can actually test that when we filter it and find interesting, use it, but also modify it, modify a little bit, chain it with another processes or another innovation. And so you do that, you leverage the innovation, but also you give also the freedom to test new product, to test new thing. And so that's how we do it. So it's basically an industrial process. No, if there is a new paper, we test it. If it's interesting, it go in the AI factory. If not, we'll retest it 6 months later.
Jean-Baptiste?
Maybe what is very interesting today is that we have 3 different kinds of business. So service business, maybe more technological business, and for me, a real product business, centered on the product. So my core business is creating apps, and my service is my app. So this is my objective. And if we have to maybe to simplify, I see 3 layers. The first one is in the journey of AI. The first one is generating model, creating model. So this is OpenAI. You are a tech company. You are coding and generating models. The second layer is you use model and you retrain this model with your own data, because you own some very useful data to optimize the results of the model. And the third layer is you don't have data, you don't have engineers to develop your model, you just have developers that are able to integrate APIs, and you can use ChatGPT very easily to create amazing product. So depending of where your value, your core value is, you just have to select first, second, or third layer. So for me, it's easy to say the third layer is the fastest way to go to the market and to test my ID. The second layer is more for me on specific product, or for more technological companies. And the first one is just if you are Mistral or OpenAI, you create those models. So you have to choose on that. And if you are in the third part and you want to compete on the first layer, I think you will you may lose your market. You will fail, because this is not a good investment for your company.
Rata, how do you decide which technology is really key for your company and which technology you should develop internally rather than take off the shelf elsewhere?
We are building a SaaS, so essentially the core model. Of course, we have to develop ourselves to have the competitivity. But what we observe rather about, I was a data science consultant for a long time, and the most important use cases are always the same. Like, for example, for retailer, it would be always be pricing and promotion optimization. And we did it for many customers, and really 90% of the work each time is the same. So so from me, I see if it's not like the core AI project of your company, I would rather recommend to try first on the shelf, because first, the data scientists are the resource that change companies super frequently. So on average, is every 1 year and 7 months. And so if you build in-house, let's say, okay, I don't talk about the core project. If you build in-house a project, and then 1 year and a half, the person is leaving, and then you have to find another person to try to ramp up on what the first person is doing, is super painful. And yeah, so it depends on your budget. Also, actually, I see AI projects like when you have a back age. So if you are super rich and you have money to go see someone to massage you, then or hire a massagist to be at your place and do it. But if not, start first with a massage pillow and to see if which is fast. And if it works already, yeah, keep your money to do other projects for me. Yes.
And you're raising a key point about keeping your engineers, your data scientists, it can be your AI scientists, happy, and to get them to stay at your company. What is key, would you say, to keep this talent? There is a huge war for these talents between startups, big companies, research labs, as we see today here at Station F. What's key, you would say, to keep them happy with their work?
So from our startup is quite new, so I would rather share my experience on
They're not living yet.
other companies. Like when I was at Dataiku, for example. Well, Dataiku is like the place where they keep talents super efficiently. So every data scientists are still there since they come. But it's super powerful. And then the structure, the culture is that we are not restricted to do the official role we are assigned to. I think data scientists are the tech people. We are frustrated if we can do more and we cannot. Like at some places, I don't know if you are only, let's say, junior data scientist and officer, you can do only that, and your company don't let you do more when you can. People will leave. And it's not what happened at all at Dataiku. So regardless of your title, if you can prove that you can do something cool, you can have a lot of responsibility. And I think it's what tech people are looking for, to be trusted, to be given chance to do something cool. Not less on the money, yes, but more on having opportunity to prove yourself. Yes.
Charles, at Alan, how do you do to keep your tech talent?
I mean, that's a really broad question, and that's also beyond AI. But basically, we try to invest a lot into the culture. Basically, we have that culture with radical transparency, where everybody has the information about everything in the company. So the people who are actually building stuff, they know about what's going on, and they can get the information. And that's actually where AI comes in, because since we have that transparency, that's radical transparency, we can now invest into AI tools to get the knowledge when we need it. So we use that tool called Dust internally which is a French company. But basically, like we ask a question and it goes into all the information that we have on our Slack, on our Google Drive, on our Notion, and it gets you just the right answer. And when you're an engineer and you want to understand the why we are actually building some stuff, and you can actually ask about to give you that answer, that's incredibly empowering. Because in the end, like, you're the one deciding on the how as an engineer. And so if you get all the information to make the best decision, in the end, you're going to build the best product.
Renaud, you have very specific talent, I guess, at Preligens, working on the defense side of things. They are probably attracted by this, but how do you handle this? How do you build your engineer and scientist team at Preligens?
Yes, I think what said Charlie is very interesting. I used to have a mentor who told that culture eats strategy for breakfast. So it's always something we try to invest. We are kind of lucky that having also what you said, this kind of mission. So the mission part is really important for us and for most of people in our company. So it doesn't suit everyone's needs, but the mission plus also the very deep tech stuff, like we are doing very deep tech AI, it gives us lots of attractivity in AI. Software also, but software is, we have more competitor, we are more, the market is broad. Basically, when you want to do computer vision, work in defense in Paris, and want to work in a startup, there is not many competitors. So this is something that we had kind of not lots of difficulty to be honest to hire data scientists. Of course, there is a new batch now of AI company, Poolside, Mistral, etc. But they are more on the LLM side, so we are not really competing for talent because we are more on vision. And so until now, it has been not. It's never easy, especially for a manager, for top talents. But data scientists and AI engineer has not been the most complicated recruitment we had.
You're not competing with the French army or the French Ministry of Interior. You're saying that they don't have this kind of talent. They outsource to you this part.
Unfortunately, not really. And I say really unfortunately, it's not with AI. It's with lots of technical engineering background. It's hard to do a career as an engineer. You can go to the DGA, but in the army itself, it could be complex. It's the same for all governmental organizations. I think it's not specific to the army. Being a tech guy in a governmental organization is not easy in terms of career, in terms of pay, in terms of everything. So
it needs to change, but
I think that needs to change, and we are trying not to push them because but yes, it's hard for them.
Jean-Baptiste, was it key for you to recruit AI scientists, engineers, and how do you manage them?
I think it's key to retain talents, and I think the basic secret sauce to retain an engineer or AI engineer is just to give them a challenging project in terms of technology and ownership, and that's it. If you have a technological challenge plus ownership, so direct impact on the business, they are very happy. And if your company is not selling shitty product, but has real vision and a real strong culture, this is a dream for you. And my feedback on that could be 90% of my first employee in the tech team are present today, 9 years after the creation of the company. 90%.
That's a great benchmark.
Yeah. So it's ownership, mission, vision, and challenge. That's it.
But I think your question was if we needed to hire specialized AI people.
Yeah, there is also a tension between hiring new talent or just training your own engineers.
Yeah, we have to do both, I think. Yeah.
You may have to do both. My bet was that we didn't need to hire AI specialists with the new generative AI wave, because the technology is so different from what was going on before. So basically, you have something completely new, and so you can retrain people who were experts in the previous generation. But I think it's much easier to actually look at the people you have in your organization, the ones that are super curious, the ones that are super smart, and really want to know and understand that new wave of generative AI, and give them time and the means to actually ramp up on that new technology. And we've done that at Alan, and I think I'm really happy about the result, because we're not paying like astronomical salaries to hire AI researchers, because those people can cost in the millions. And at the same time, we have people who have ramped up super quick on that new technology, and they can actually deliver after like a few months.
Actually, I have the experience that having a mix of people coming from AI or, for example, the MVA or very strong scientific or AI background, but also having software engineers who train themselves in AI, are a very good mix. Because at the end, you have to put your AI in production, you have to have some code and run somewhere. And if you have only researchers, etc., sometimes it's challenging. They are not really interested in code, they are not really interested in deployment. Whereas if you have a software engineer who is trained in AI, there is lots of tools, lots of things that he could use to do iterative R&D, production, and put that in the hand of the clients. And I think the mix is really interesting in terms of tech culture.
In fact, I think I misspoke a little bit, because we cheated a little bit at Alan, because we're very close to the Mistral team, which is external to us, so we don't have to pay their salaries that are like pretty high. And at the same time, we get a lot of information, a lot of knowledge from them, because they're working from our office, and so we get a lot of exchange of information and know-how, which is really key in that new generation of AI.
Software engineer is super hard to hire. I don't know if you guys have problems, but for us, it's the rarest resource that every startup we know are looking for and have a hard time. But data scientists nowadays, there are a lot. Everyone is like learning to be data scientist in some months, some quick course and they're a data scientist. So yeah, it's much more harder for us to find software engineers.
But it's the same at each decade. 10 years ago, it was iOS and Android developers. It's the same. It's each time it's the same problem. AI is very new, and so to convince the best engineer to come in your company, you have to work on your culture, your mission, your vision, your product. And I think this is the best way to hire great talents, because they will be very involved in the project, and this is the key for in a very specific business, which is mine, product-centric, user-centric in the B2C business. But
that's interesting that you mentioned the mobile engineers 10 years ago, because 10 years ago I was at Facebook, and we had a huge shortage of mobile engineers. We were doing everything on web, and what we did was just like we could not hire people outside, because there were not enough people knowing how to code on iOS. And so what we did was to train a lot of people internally to that new stack. And those people became iOS engineers. And I think that's super effective.
Maybe we have time for one last topic, which is sovereignty. Obviously, with these AI services we're mentioning, whether it be Mistral, OpenAI, they are using your company data. Any AI solution needs to be trained on data. I just want to know what's your position on this. There are many companies French companies afraid of using OpenAI. They see it as a black box. They don't know where the company is going to end up, how it's going to be used. What's your position on this?
I think I can start, because that's a topic like sovereignty for us. It's I think what you have to do, what I wanted to do with the company since the beginning, either in cloud, in SaaS solution, everything, that is really to be pragmatic and efficient. Meaning, if you know, if as a defense company you have the tendency, okay, I put everything air gap. I don't use a SaaS. I don't use cloud. I don't use US ChatGPT or kind of thing. But if you do that, you are not efficient, and you lose. You have a strategic downside, so you will lose. So in fact, you have to work a little bit more in detail and understand in your company, this is something I can put on SaaS. This is something I can put in the cloud. This is something I can, okay, this thing is probably like taking my data, but what data I'm putting in, is it okay? Who is going to, you know, is it a company who is getting my data? Is it government? Which government? So I mean some kind of detailed analysis. And so at Preligens, we do everything. I think we have used every cloud provider. And we have a center in Rennes where we process classified data when there is like barbed wire and, you know, like, okay, and we'll use also cloud, and we use all of that and trying to deploy tool and processes for everyone in the company to be easy to choose. Like, okay, if I do that, I'm going to use this kind of thing. If I do that, I'm going to use this kind of thing. And it takes a lot of time from you. We have a big legal compliance IT security team to be able to do that. And I think it's key. Otherwise, if you don't use the last technology, you can be sovereign, but you are like 5 years behind. So it's great to be sovereign, but if your solution is shit, yeah.
I think the first key is respecting GDPR. So basically not sending sensitive personal data to OpenAI. I think that's super important and
super simple.
Yeah, super simple too. I mean, not doing it, but there's ways to go around it. So you could have like OpenAI on Azure in Europe, which can get you like okay in terms of compliance with GDPR. Then, like, if you can't use that, you can actually use open source models that you can have on Hugging Face, and then use them like to for your applications. And then, like, yeah, I mean, sovereignty is key for companies. Like, but in the end, like, if you don't have a product that works well, like, it won't matter. Compliance needs to come first, but then like you really need to understand like which are the categories of data that you can process in which setting, and then like deploy accordingly.
Rata, what's your position on sovereignty?
I think it depends on the size of your company as well. Seeing that we work a lot with mid-markets, actually they seem to be less restricted than that. Like, for example, retailers, right, they are suffering right now, so they're like, please help take our data and help us.
They don't care about sovereignty.
Yeah. I mean, yes, like they are dying. Just take our data and give your recommendations with AI and save us. What we in our solution, we don't use personal data, so that's easier. But we can ensure our customers as well that okay, on the data we take, we don't use it for others. That you know, the models is performant enough if we use only your one customer data for one customer is what we do. But generally, very small numbers of customers are worried about it, and people who are worried are like top super well-known companies. Yes.
And Jean-Baptiste, one last word on this.
Yes, as far we are concerned, we are in a worldwide distribution, so 182 countries, 98% of our audience are abroad. So we are totally not, we are not very well known in France because we are all over the world with 600 million users to date. So for us, there is not a lot of things new because we already have this kind of problem in the past, and so we have to look at the RGPD and the DMA, which is going to be released next year. So we just have to respect all international or local laws, and after that, for us, it's not something new. So we are continuing our business like that, and it's a B2C business. So users are not sharing very deep personal data. We are not working for the state. We are not working. We are not enable plan to fly. So it's less important for it's less risky, exactly.
One word to add: in order to preserve sovereignty, we need leadership, and in order to preserve that leadership, we need to share a lot into the commons, and notably open source. And so, as much as possible, all the companies should contribute to open source and make sure that everyone can benefit of the advances in technology that we've made in the past few years.
All right, we'll finish with that. Thanks everyone for your contribution.
Thank you, Benoit. Thank you, everyone, for your time. Thank you so very much. We'll be here in the next session in 5 minutes. We'll take a quick break in the middle. At 4:20, you will have Martin Raison to talk about LLM Cure for the healthcare software. You can see it right here on the screen. In 5 minutes before a break.
Test.
Alrighty, thank you everyone for being here with us this afternoon. We're very pleased to welcome Martin Raison. He's the co-founder and CTO of Nabla. Let's have a talk around the healthcare industry and healthcare software in particular. Please help me welcome Martin on stage.
Everyone, this is Martin from Nabla. I'm so happy to be here at AI Pulse. And I'm here to talk to you about how we use large language models at Nabla to improve healthcare. So first, just a quick word in case you haven't heard about Nabla before, about what we do. So Nabla, our product Nabla Copilot, generates clinical documentation automatically for medical consultations. We do so by automatically transcribing the consultation, the audio of the consultation in real time, and processing it with large language models to extract and structure relevant information into a clinical note. That means during the consultation, the doctor can focus on the patient instead of focusing on the computer and save about 2 hours a day. And we do so at a rate of millions of consultations a year. So hearing that product description, you might try to think about how you would go about building this kind of product. And you could probably build a proof of concept relatively easily. You might think, I'm going to put a microphone in the consultation room. I'm going to stream the audio to a generic speech-to-text API, get back a transcript, send the transcript to OpenAI, and boom, I get a clinical note. Easy, right? So the goal of this talk is to show you all the obstacles that you'll find along the way and show you what it takes to go from such a very simple proof of concept to an actual product used by professionals around the world. Okay, so when you roll out your proof of concept, you'll get a lot of feedback from doctors. First feedback that you'll get is that this is pretty damn slow. What you have to realize is that all the transcript from the consultation has to be processed by a high-quality large language model, which takes a lot of time. So you have to work a little bit on your infrastructure to make sure that you can make things as fast as you can. If you take 5 minutes to generate a note, you're wasting the doctor's time. For example, we noticed pretty early on that if you use GPT-4 through Azure instead of OpenAI, well, it used to be twice faster. But there's more you can do. Typically, providers will have capacity in multiple regions. So if you have capacity in multiple regions, you'll notice that in a given region, the same query can take 10 seconds in the morning and 30 seconds in the afternoon. So it's really important to actually monitor the speed of the API in various regions and load balance across regions in order to get the fastest available speed at any point in time. If you do that, you can actually make your proof of concept faster by a factor of about 3 or 4, which is huge in terms of user experience. One useful aspect of language models is that if the query is long, the query is going to be slow anyway. It's going to take about 10 seconds, so latency doesn't matter. So we don't really care if you have to cross the United States in both directions in order to find the fastest endpoint. Okay, second feedback from doctors. It actually breaks for long consultations. Why is that the case? Because the transcript for 30-minute plus consultations, which is actually a significant part of the consultations, is actually too long for today's language models, which have a limited context window. Also, you'll notice that models like GPT-4 32K are twice as expensive as GPT-4 8K. So you have to be mindful of that. And then you have models like GPT-4 Turbo, which are supposed to come up with a much larger context window. The thing is you also have to make sure that all the context window is actually used properly, which is not always the case. So we have a different strategy that we're using. We actually chunk the transcript into small parts, and we actually progressively enhance the note during the consultation. So we take the first chunk, we get the first version of the note, and then each time we get a new chunk, we provide the latest version of the note along with the new chunk in order to get an improved version of the note. And if you do it this way, at the end of the consultation, you've pretty much done almost all of the work during the consultation, and so the final note generation is pretty fast. And also, you're not constrained anymore with the context window size of your language model. Okay, another example of problem. This one is pretty important. Doctors will find that your product works most of the time. But this is the status page of OpenAI for the month of November. LLM APIs, they're not as stable as other APIs that we're typically used to. And there's a good reason for that. They're constantly trying to ship improvements to models, and they also have to meet crazy demand. What that means is that you have to defend against that as much as you can by adding redundancy. I talked about using various regions before. That is a good one. You can also try to make sure you can fall back on a different model if the current model if your best model basically starts failing. And also, of course, you can try to have retries, but that's going to make your node generation longer. So in any case, you will also have to provide a graceful fallback in your UI. So you have to think about that experience to make sure that you don't waste the doctor's time and that they have a way to retry in the future if really there was nothing you could possibly do. Okay, now that technically everything works, another issue you'll have is that while the proof of concept can get you a cool demo and produce a note that's actually believable, doctors will often tell you that this is not exactly something they can use directly and put in the patient records. So that's where you have to actually get to work. It will take many iterations over the ways you're using LLMs in order to get something that corresponds precisely enough to the way doctors are used to writing notes. Also, there are many different medical specialties, and there are many different ways to practice medicine. So you have to make sure you describe precisely what you want. Try to avoid prompt hacking, things like adding random keywords because you noticed it works better on one particular example. And this is sure it's going to break as soon as the model changes. And this won't generalize. But also, something that's been very useful for us is to actually let the users help us with that work. So in the product itself, doctors can actually try to regenerate the note with custom instructions. The cool thing about this is that this gives super precise feedback about what doctors are looking for. And this really, for us, was a great source of enhancements for the default ways we use to generate the notes. All right, another famous problem of LLMs is hallucinations. In a healthcare context, this is obviously unacceptable. So how do we defend against that? The first line of defense is actually in the prompt itself. You can tweak them, engineer them to make sure that they're targeted towards more factual notes. You can instruct the LLM to actually only include in the note stuff that was explicitly mentioned in the consultation. But that's not all. Another strategy that is particularly efficient is to actually do something that we call verification prompting. So it's kind of a post-processing step that you use. You can take an individual fact in the note and actually ask a model, was this explicitly mentioned in the conversation? This will actually give you amazing signal because this is a much simpler question for a language model. And so most of the time you'll be able to solve any hallucination that may have that may remain after the first step. But in any case, you will not be able to provide 100% guarantee. So you have to structure your product so that it is super easy to actually modify the output, proofread, fix content, and send feedback. This is an iterative process. And another more tricky one is some doctors will tell you, well, that node is missing this piece of information. But then if you look into it, you'll find that the information was actually never actually mentioned out loud during the consultation. So of course, there was nothing you could do. And there are very good reasons why doctors may want to include information in the note that wasn't actually said to the patient directly. For that, well, this is more about product development. You have to have some ways, easy ways in the product to have shortcuts for the doctor to easily complete the note. But also there is something you can do with language models directly, is to include some patient context along with the transcript. And also, this is useful when you're having to handle follow-up consultations, because usually not all the context from the previous consultation will be repeated in the new consultation. However, the technical difficulty in that is that you will want to have more and more context if you have a patient that's consulting often with a doctor. And so then you get back to the problem of how do I handle very, very large queries with your LLM. So far, I've only spoken about the language modeling part. And I almost considered that the speech-to-text, it's a solved problem, no one cares about it anymore. Well, it turns out that's not actually true. So first, we had to actually survey all the available speech-to-text APIs out there to find the best one. But even that was not enough, especially if you go into healthcare and you start having conversations that are very heavy on medical terms, then the performance starts to go down. So what we do today is we actually had to fine-tune our own speech-to-text model. Great news is that there are great generic open source models out there right now. So typically we use Whisper, and we fine-tune it with our own data set. This makes for a great performance with medical terms. And so right now we actually use two types of language models. We use a generic language model that's going to provide very fast real-time feedback during the consultation. And then we use our own model, which is a little bit slower, but still the speed is very much acceptable, but the performance on medical terms is much better. So that's the best trade-off that we have. Okay, so that is for the problems that the doctors will report to you. Now there are other obstacles along the way. This is a message we got from Azure one day. And so basically they are changing the model. And the reason is simple. They want to improve the model over time, which is great, right? The problem is that it can actually break all your prompts, even if the model is supposed to be better. And also it will decrease the consistency of the product. That means doctors, when they use the product, they come to expect something specific from Nabla Copilot. So how do we defend against that? We built a good evaluation infrastructure. To do that, anytime we get some specific feedback about the notes, we try to turn it into a unit test, something like a unit test. Those unit tests are things like, is arthritis mentioned in the history section of the note, for example? Those tests, you actually use language models to run them. And because it's like simple yes-no questions, usually you'll get very good performance on them. And if you have a large number of those unit tests, anytime you get a new model, you can very quickly evaluate it and get a very clear picture of the performance. In general, we also try to have precise numbers to evaluate how much of the facts from the conversation were actually correctly pulled in the note, and how many things that are mentioned in the note are actually relevant in that context. Okay, this one is fun too. When you actually want to deploy your product in a very large healthcare organization, of course, you'll get a few questions. So you not only have to convince the doctors, but you also have, of course, to convince the information security teams. We're talking about healthcare data here. This is super sensitive, so you have to be very serious about it. By the way, this is a real question. If you don't know the answer, there's no shame, because Google has no clue either. So, how do we tackle this? So first, we try to simplify the problem as much as possible. We don't store any data by default. Actually, we don't actually need that. But we still process it. And so we also have to ask our API providers not to store any of the data that they process, which requires a custom agreement. And we also need control over the region of processing. Some customers will want all their data to remain in the US or to remain in the EU, and so on. And in terms of compliance, of course, you have to comply with GDPR, with HIPAA in the US, and probably get SOC 2 and ISO 27001 certifications. All right, and you get a bit faster. So, it's expensive. How can you decrease costs? We're transitioning away progressively from using generic models to smaller fine-tuned models. Typically, for the simpler tasks, we saw that you can actually replace the generic models with models like Mistral 7B, which are fine-tuned on our problem-specific datasets, and we get about the same performance. This will go a very long way. Then, what about testing? If you have LLMs that is intertwined with business-specific logic in your code, that means your test suites will have to use LLMs, and this will make them pretty slow. We want to have super fast test suites because we want to run them all the time, and we also don't like mocking APIs because this tends to make tests not as realistic. What we use is we use an internal proxy, a caching proxy for our continuous integration and development environment. This means you can run tests as much as you want. It's super cheap, and because you make the cache expire at some point, this means that the test suite will always end up reflecting what actually happens in production. Then, how can I test new prompts? At the beginning, it's just your machine learning engineers who are just writing all the prompts, and they're just putting them deep inside the code, and everyone is happy. But the problem is that it's a shame that the people who talk the most with the users actually can't contribute to that effort. So you'll win a lot by actually setting up a dedicated testing environment where it's easy to tweak the prompts and use them together with the production code to get instant feedback, not just on the particular example that you have in mind, but also get a feel of how your suggested change will perform at large using the evaluation dataset. And the last one is the note is far from enough. Doctors need more, and you can also help patients too. So why do doctors need more? First, you have to integrate with the software that they use. The software that they use protocols like this. Those protocols, this one is HL7, they were created even before HTTP. So get ready for a lot of work. Then there's more you can do rather than just generating a text note. You also want to structure content as much as possible. So typically you will use ontologies like ICD-10 or CPT to extract specific codes that you can actually inject into the software that the doctor uses. And in terms of helping the patient, something that Nabla Copilot does is actually helping the doctor generate patient instructions, which is the summary of the consultation that you can give to the patient so that they remember all the important parts of the consultation. That means the patient doesn't have to take notes during the consultation either. All right, so after solving all those obstacles, the reward is pretty obvious. Doctors fall in love with the product. I've never seen anything like that on any other product I've worked on. Basically, doctors are so overburdened that this really changes their life. We've even seen feedback where they start actually talking to Nabla Copilot as if it were a real person. And this is great, because this is exactly where we want to go. We're all building a complete medical assistant that is designed to help healthcare professionals in every aspect of their job, allowing them to focus on the patient and on what they do best, which is providing care. And we can't wait to get there. Thank you.
Thank you, Martin. Thank you so very much, Martin. We're going to move on to the next session right away with Mathieu Rouif, who is the co-founder and CEO of PhotoRoom. Mathieu will be giving you a lot of insights on how you can build user-centric generative AI product. Mathieu should be joining us in a second. Please help me welcome Mathieu to the stage.
Hi everyone. Happy to be here, and thanks for taking the time. So I'm Mathieu. I'm the co-founder and CEO at PhotoRoom, and at PhotoRoom we're the #1 photo generative AI app in the world in terms of traffic, and we empower every small entrepreneur, every small business in the world to create amazing studio quality photography. So that's the app. We're on all platforms, iOS, Android, web, and API. And really what's different, I mean, Martin was just before, what we do that's quite different from other research AI company at PhotoRoom is that we are a very user-centric AI company. So we take the feedback from our users and we develop our models, our tech from that. And that's quite unique. And being, well, the number one in the world for the photo side, we have some learnings from the past year building Gen AI, and I'm very happy to share that with you today. So first, to get into the context, who in the room has ever sold something online? Can you raise hands? Yeah, so that's good for my stats, a lot higher. So more than like 60, 70%. And who has been very satisfied with the photo they're taking of the object? And that's close to zero. So that's amazing. I'm going to reuse that stat. So yeah, you have you have a billion people selling online, 500 million, and well, today when you sell, that's what happened. What you see on the left. So you have most transaction happen on a mobile phone, and more than 50% of the pixels, as you see, are the photography. So today, commerce is a big photo, a price, and a buy button. And so taking a good photo is paramount for the success of your sale. And that's the problem we solve at PhotoRoom. So I'll start with a quick demo of what we do. And then I'll move on to a bit of our learnings in the past years, and on the past year, just 1 year of Gen AI, it's quite recent. And then share some technical sneak peeks of what we're doing under the hood. So first, with the demo, that's the PhotoRoom app on the web. And I'll share what happens with product photography. So if I drop some sneakers here, first do a cutout, and then you'll see some of our LLMs plus generative AI models for the image. First, we understand what your product is. That's very important to give you the best image. Then we generate the best scene for you. That's another model. And we render it, like small resolution, and then upscale. And as you can see, it's extremely fast. You can see even the glow of the shoes here, the shadows. And this is, the fourth model. And if you want, and you have some inspiration from an image, you can also start from an image itself or the background. So here it's a basketball court. And, it's important when you sell to have control as a seller, a professional. So you can even get some part of your image that doesn't really match to be changed or removed instantly. So that's like 6 different models we use in the app. And last but not least, some e-commerce sellers, some small business, they want control on their brand. So they want some colors, and they want exactly this color to be used. So let's say this is my color. And I have this, we have a very unique model, which is generative, that creates shadows that would look like a studio shadows, exactly, and that we generate instantly so you can get control. Even generate floating shadows for your shoes, which is pretty neat. That's a fun feature in the product that is kind of my favorite. So here you can see all the generative features, the LLMs that we have in the PhotoRoom app today. Now, that's been in the training, in the building for the past year, and it has a tremendous impact, as you imagine, being the number one in the photo space on our business. So PhotoRoom, we doubled our revenue in the past 6 months with the generative features. We moved from more than 50 million in ARR, $50 million. But more importantly, users are using us a lot, more than 2 billion images generated, and they increase their sales. So we are delivering value for them, and they sell more. 2x is kind of an average. We have people 10x, 20x their sales using PhotoRoom. And now you even have, that's a new kind of business, you have e-com on Instagram, which is only AI generated. So you have this kind of shops that are new, didn't exist a year ago, to show you the impact of the generative AI and PhotoRoom on the economy. That really this kind of shop didn't exist before. And to give you an idea, this which image in this Instagram shop is real? Well, none of them. All AI generated and come from PhotoRoom. So this is how people are doing. This is commerce in the future. And it's taking off. It's not the future. It's happening right now. It's present. Now, that's a beautiful story. It's been it seems to be an overnight success. But let me tell you a bit more on how we did it. So that's a year ago when we started doing generative AI in the product, and so you see the growth we have. And now we started working on the generative AI features and launch it. And so that's where the amazing thing happened, or actually didn't. And that's the first version of PhotoRoom Gen AI, and didn't have any impact on our growth. So we got back to building and come with our V2 of our generative AI features and relaunch, and now it took off. And so my point here is, well, it's a new way of building software, but you don't get it right the first time. And we did that and learned it the hard way in the past year. And let's dive into, well, what we did that we learned in this gap between V1 and V2 that was amazing. That changed, actually. So 3 learnings on that. Well, first and foremost, so as I said, we started like a year ago. We talked with, we literally, when there was this, the diffusion model, we stopped with Elliot, my co-founder, and just here. And we worked on, this is transformative. Nothing is going to be the same in the photo editing space. It's the biggest innovation of the year or the decade. And so we need to work on that. And we paused for, we did a hackathon for a week that transformed into actually 3 months working on this new feature. And but that was the right decision. It's really the new way of working for software. It's true for photos. It's true for any software. So the first thing we learned is that speed matters. And our V1 was actually quite slow. So you would put a photo and you would like a product photo. The result was amazing, but you would get the image 3 minutes later. It was extremely high quality, but it took a lot of time. And well, people might not have the exact number, but an average session on mobile is 6 to 7 minutes. So if you take half the time to create just one photo, then people would just drop. So we got back to the drawing board, changed a lot of things. We changed the architecture. We made a lot of optimization at the low level. And on top of that, we really we made it iterative, so you have low resolution, then higher resolution, to get to 2 seconds. And so this 100x increase is the biggest reason why we were successful, and especially on the mobile experience, when you're talking to tens, hundreds of millions of users, that matters a lot. And sometime when on the drawing board you test it, you just look at the final result. But well, if you want to have a product that's interactive, 3 minutes is not acceptable, and it's better to do trade-off or iterative so that it works. And so that's the #1 learning. 2, we all talk about generative AI, and there's this part of that's called hallucination. So I don't know if you can see, that's a cup that we want to sell, and we asked our first version of V1, can we have a good background for that? Can we have a good scene to sell my product? And well, it's kind of a little game here, but if you look at the images on the right, at the bottom, well, it's never the right number of patterns of lines of different colors. It always changes. And well, it's cool to be creative, but when you want to sell something and you don't want people to ask for a refund, well, it's better to have exactly the same pattern, especially if you're selling, well, anything actually. But if you're selling sushi, if you're selling food and you hallucinate some ingredient, that doesn't work at all. So that's the second learning, is to stop the hallucination. If you're selling a product, it should be exactly what you take into photo, and you need to find a way not to hallucinate. And it goes well with the past talk about how do you check it's accurate. So depending on your users, you need to find the right way to serve them and actually deliver value. Third, what we realize is if you do by scale, and a lot of people here, I'm sure, have learned to write prompts in GPT, in Midjourney. Well, actually, if you go by scale, people don't know that, and we tend to forget it after a few months. People don't want to write prompts. It's just they don't know what to write. It's a white page problem. And so they start with, so we try to find a way to do that. And that's why you saw in the demo, we invented other models that actually help you get that and help you get started, kickstart the creation. So we have one model that will find the caption that would do the description of your product you're selling, and then another one that will suggest the best prompt for what you do. And these are 2 different models that we optimize and really, well, that improve a lot of funnels, so most of the user can get to the actual like a first result that's really good for what they do. And that's been a major change and major improvement for us in terms of adoption. Right, so we have 3 learnings. Now, what do we do when we go like under the hood? What do we do technically to go further and improve even more on top of our initial learnings? So that's why we decided to train our foundation model at PhotoRoom to deliver the best images and the best experience for our users. And we did that for 3 reasons. First, we want to control the data. So a lot of B2B and small business, they are afraid of a lawsuit that would happen with training on different images that they don't derive the right on. And so we wanted to provide this experience where you don't have to worry about that. And to do that, you need to train from scratch. Second, well, we want it to be even faster. 2 seconds is good. If you want to iterate a lot, it's not good enough. And we have some trade-offs that we can take in the architecture, but that requires, again, to train from scratch. And that's the second reason we're training our own model. And lastly, well, we have 20 million of users that are using the app. And then these users, they provide a feedback on which image works, which doesn't. But we need to go back to the building, the foundation of the model to incorporate these learnings. And that's the last reason why we wanted to train our own model. And it's not done as an experience, but I want to share a bit about what we're doing. So first, this is the GPUs that you use for do that. So you need hundreds, thousands of them. This is quite big to it's actually an industry to get there, and that's why we're here with Scaleway. So that's the first part. And then, well, that's the beginning. I mean, it's like a little baby. That's the beginning of the learning of a model that we have at PhotoRoom. And this is these are some checkpoints of a diffusion model that is learning to draw a bottle of a marble table. And you can see it's getting poetic, but try enough, you can see how it learns the shapes on the way. And well, you can see how more accurately it gets over time. And now you have like later checkpoints that you can get from PhotoRoom. That's still early, but well, you get pretty high resolution. And this is an early glimpse of the PhotoRoom AI models that start from scratch. So pretty excited about that. It's coming in a few weeks in the app. So really, it will be amazing. Now, one last thing about e-commerce. One thing is like everything you see on the app, on the mobile web, it's also available as an API. So we have big names that everyone knows, and you can see the logos here that are using our PhotoRoom API today. And if you zoom in on Wolt, which is one of the biggest food marketplace in the world, well, most of their images now are generated with PhotoRoom AI. So there is trust in the product, but it's also beautiful images that makes more sell. So that's the big win for them. And well, our mission is to power like most of commerce photography in the future. And we're also happy to work with partners directly, marketplaces and e-commerce website to do that. And to show you a bit how it goes and how fast it goes with the GenAI features now, here's a little video of a famous shoe seller, and you can see as you scroll that, well, this is all the classic product photography, but live, well, you can start to edit and be creative. So let's picture these images on a field track, and this is using PhotoRoom API. And you can also adapt to events like this one, where, well, let's say it's, well, you know, we all know it's Christmas in a few weeks, and live you can replace the background with some Christmas theme, and you can adapt. There are infinite options. You can adapt to your users to the time of the year, and everyone will have a different photo in the future, and that can be delivered through PhotoRoom Generative AI API. And here we go. So yeah, thanks for listening. I hope the learning points. Thanks.
Amazing. Thank you for the glimpse into the future of photos. Thank you so very much, Mathieu.
Thanks. Yeah, and I'm here if you want to discuss GenAI or photos.
All right, we'll take a quick break before the next session with Suzanne Vergnolle, the CEO of Golem. I'm very excited about the next session, so please stick around. 5 p.m. sharp, we'll begin. Hi everyone, can you hear me? All good? Thank you for being with us, Central Stage. Thank you for being online as well. I'm very pleased to welcome our next speaker. This is Kilian Vermeersch, the CEO of Golem. He's going to talk about generative AI, as you can expect. Please help me welcome Kilian on stage.
Hi, I'm Kilian Vermeersch. I'm the CEO of Golem.ai, and I'm going to talk today about the subject of AI, mostly in sensitive and critical environments, and how AI can benefit those sectors, and the other way around, how deploying AI in those sectors can help make AI in general better. So we'll start by going through a few definitions just to agree on what we're talking about, because as you've seen in the past few months and even today, I guess, AI is a bit of a mess. And then we'll go through a few use cases, which are anonymized, but use cases very close to what we currently do at Golem.ai. So first of all, just to agree on like a few fields of AI, because we talked about analytical and generative AI. So analytical AI is kind of the old-fashioned AI in some way, in the way that it's an AI that provides a result, which is usually structured data based on unstructured, mostly unstructured input, sometimes structured too. Generative AI, well, I think you've heard about it enough today. It's an AI that generates content. The fun thing here is that I've built a structured slide here with use cases for both, and nothing here is precise, because basically anything in those two lists can be done with the two types of AIs. And that's one of the things that makes AI complicated nowadays, because you need to make choices, especially when you're an AI buyer. And those choices are usually really hard to make. So today I'm focusing on sensitive environments. But in general, a lot of what I'm going to be saying today is actually a good way to help make those decisions. So what is a sensitive or critical environment? That's just to be more precise about what we're talking about. So I gave a few examples here, like health data, like anything related to defense or national security, or anything else, like even a business critical case. And one last point, which is actually very frequent, is that sometimes a customer will consider whatever data you're manipulating to be critical, and you have to act as if the data or the environment is critical. And with critical environments come constraints. The first one, and which is a big problem in AI, comes with low or difficult access to data. If you're working with, I don't know, an army command and control center, for example, they're not going to just dump all the documents to your company to help you train your model. That's not how it works. And even if you go to the office, then you won't have the GPUs you need to train those models. Also, it often comes with on-premise or even offline deployments. So you won't have access to a lot of external services. You won't have access to easy deployment tools. Usually, in terms of software, you won't even have access to simple things like Kubernetes or even containers sometimes. And this creates a big paradox. And this paradox is that critical environments are the environments that require the best AIs because, well, they are critical. And the constraints they set makes these deployments a lot harder to do. So they need better AIs, and they create an environment where it's harder to do a good AI. So at Golem.ai, we've had a few cases where we had to go through this and where we had to manage these kinds of AIs and these kinds of deployments. Then to have either on-premise or SaaS deployments where we need to have a really, really high confidence and trust rate. And besides this, there's also a legal framework. And I think we had a really good introduction to this morning. Like some people are getting even angry at this. Because the legal framework is created in a lot of complexity, often for good reasons, because regulations are needed. We know what happens when you don't have them. So that's just a few examples of them. Like the AI Act that's creating a lot of noise right now, GDPR, that's still there. Some people forgot, but GDPR is still there, and still something we have to respect even in AI. And all of the other things here are usually laws that are not dedicated to AI, but that still apply. And I think the most important one for me personally is liability and accountability, because AI is usually used to make decisions or to assist in decisions, meaning that responsibility is involved. The most common question on this is autonomous vehicles. Like, who's responsible when a Tesla vehicle has an accident, for example? And all these other points, like intellectual property, has been a huge question mark right now on all the generative AI models who are basically absorbing all of the internet, all of the books and everything else to make good functioning models. So now that we've been through a few explanation and definitions, we're going into the main part of the talk, which is use cases. And these use cases will all be presented in the same way. We're looking at a problem we want to solve. We have constraints to solve this problem, and we did have to find a solution for them. So first one, health insurance. Automatic processing of incoming requests on personal injury claims. So that's some sort of a complicated use case. First of all, we're talking about insurance. Insurance is already one of the hardest sectors to put AI in, because they have a lot of data that's not structured, and they have a lot of different problematic laws they have to respect, because it's very regulated. And at the same time, so we're talking about health data, because it's personal injury claims. Like, what happens if someone, I'm going to go in a bit of a dark example here, like someone lost a leg and they need to be reimbursed by the insurance for the rest of their life because they need help. Like, the insurance is usually going to say yes, and sometimes they're even going to say no, which is even more frightening. So, in terms of constraints, first of all, it's health data, so you need all the regulations and agreement to be able to just process this kind of data, even if you're not talking about AI. You need to be explainable, and in this case, not like, of course, you ethically need to be explainable, but you also legally need to be explainable, because insurance, as I said, is very regulated. Those decisions must be made without bias, and must be made in a way that follows specific rules that has been set in laws and contracts. And also, which a third point which goes very wrongly with the two others, is that the documents are very complex, meaning that in these documents you're going to have handwritten documents by doctors, which for anybody who did OCR is basically the worst thing you can work on. And also is going to be very specific ontology, very specific vocabulary, and there's going to be a high amount of documents, because every case is going to come with like 5 to 10 documents usually. So what do you do to solve this? In this case, that's usually a pure analytical AI problem. You're not trying to generate any sort of content. You could try to, but that's not the goal we had here. And in addition to always like keeping the decision and the help that was made, you need to keep in storage the process that was used to make the decision. And that's because a few months or a few years later, someone can ask you why you made this decision. And you need to keep this, because if you only store the fact that you accepted the contract and that's all, then you won't be able to answer to anybody, and especially to a legal authority on this. And the last part is to keep the human in the loop. And again, as I said earlier, this is of course an ethical thing to do, but it's also a legal thing to do. Like currently in France, you won't be able to ask a machine to completely make a decision on an insurance contract. It's not actually acceptable. So usually the best way to go is to give the human the capability to make the best decision as well as possible. So you're going to present the human with the extraction information, and that's actually going to help reduce bias, because you're always going to make the human make the decision based on data that's presented in the same way. Second case, decision support in national security. So that's I would say, the most basic one in some ways, which is that since you're in national security, then you don't have, you know the environment is critical, and you know why it is. And also, that's the case where you're always on premise. So in this project, we were and are assisting specific personnel to make more informed decisions. Like they need to have access to what happened in the past to make better decisions about the future. We don't want them to make the same mistakes over and over. It already happens enough. And so this case had completely offline environment connected only to internal data. So that's the first complicated case. It's not even an AI problem, it's just an IT problem. You have to be able to deploy something that's complicated in a closed environment. Limited hardware. Usually, especially external data centers are not going to provide you with 500 GPUs or even just a lot of RAM to be able to deploy a complex AI system. And you can't get access to the data. You are not going to be able to take the data back to your office to make anybody work on it or train on it. So in this case, the best solution we found is using, and that's a good thing, it's good, that's what we do at Gorintin.ai, but it's an analytical symbolic AI. And symbolic AI, for those of you that don't know, is AI that's trained on structured data, not unstructured data. So it's not trained on example, it's trained on a structured ontology and structured relationships between those elements in the ontology. And another point, which is one of the main points of the conference today, is that only use sovereign tech or open source tech. Because in this case, you want sovereign tech. You don't want to be dependent on another country when you're talking about national security. So what we did here is, well, we used our own AI and we used external tools like, for the OCR, for example, we used Tesseract. Third case, core business deployment. That's the case that's usually forgotten about because it's usually not considered critical, and so a lot of projects of AI fail because of this. Because that's an example of a project that doesn't look critical. It's processing. In this case, we're processing codes and order emails. So just sales data, and it's not going to be considered as critical for most people. But we are processing basically more than half of the business of a company that has more than $1 billion in revenue. So they have a lot of money to use if it doesn't work well. So in this case, you have to consider the environment critical, even if it isn't when you first look at it. And sometimes even the customer will have difficulties to tell you if it's critical or not, because they don't know if it is. They only know it on the business point of view. So constrained core business. So you have to have a really high reliability, and we actually saw it because, as most companies do, we did have some downtime, and we did have messages from the customer telling us they are losing business because we had some downtime. So it's a really important thing to do, and having a really high reliable tech is even harder when you're talking about AI than when you're talking about a classic system, because the load is very varying, you're working with a lot of new tech, and things like that. And second thing that goes together with it is the very low error tolerance rate. That's the last slide. And in this case, you have to be able to have high quality results and to be very adaptable. So what did you do? Analytical AI again. Another case, to be transparent, the second case is still something we are studying, is using generative AI to generate answers. So you can use analytical AI to categorize the messages, and then use generative AI to generate answers for the non-critical messages. And update the AI knowledge base regularly based on what's happening, just to make sure you keep up to date, because data drift is a real thing. So, as a conclusion, the main thing I want you to remember from this conference is that the critical environments are less than 5% of the market. So it's not that big of a market. But the main thing is that making AI that works in critical environments makes better AI in general. Because if you make those AI work in the best way, then you'll be able to make those AI work also in very simple environments and in environments that don't have all those constraints. And that's why there's so many good tech we have right now that comes from the medical sector or from the military sector. It's because they were built in complex and hard environments, and now you need them in your general life. Thank you for listening.
Amazing, Dov. Thank you so very much, Kilio. Thank you for your time. All right, next session will be in about 4 minutes. We'll have a massive panel to close the day on next-gen technologies. A lot of executives from HPE, from CPER, from Cornella, from Scaleway are joining us on stage in about 4 minutes. Good evening, everyone. Thank you for being with us here in the central stage. Super happy to welcome you for the next panel. It's a huge panel, you see, on next-gen hardware. So we're going to welcome in this session Mark Armstrong. He's an EMEA Vice President for High-Performance Computing and AI Solutions, of course, for Hewlett-Packard Enterprise. Then we'll have James Coomer. He is a Senior Vice President for Products at DDN. Then we'll have Philippe Noton, the CEO of CPearl. And finally, Jean Senelard, the CPO of Quandela. And this session will be animated by Alban Brias, the COO of Scaleway. Please give them a big round of applause to welcome them on stage. Welcome. Come in.
So, hello everyone. Thank you for being there today. We have a long AI day about training, about inference, about fine-tuning. On my side, I come from the digital sector. And for me, I find it really important to always talk about raw material. And for digital, raw material is hardware. And this is what we are going to talk about today. And there are many concerns about hardware. Most of it will be environment, it will be accessibility, and it will be sovereignty. And so we have an amazing panel today to talk about all these topics. The first one I want to talk about is maybe what the difference between training, fine-tuning, and inference. We are today at the beginning of the AI journey. For the moment, it's mostly about training, about marvelous ideas that everyone has. But then we will have people using AI that will mostly go to fine-tuning, and then have a topic about inference. And for the first topic, I would like Mark, if you agree, to talk to us about your vision on this.
Sure, yeah, thank you very much. And good afternoon, good evening, everyone. My name is Mark Armstrong. I'm the VP responsible for HPC and AI across Europe, Middle Africa for HPE. So, I mean, yeah, that's a really interesting question. And, HPE are deeply involved in supporting our customers and our partners at the moment around all of those aspects, but particularly training right now. And that plays to a lot of HPE's heritage. You know, when you look at the problem statement around training, this is a huge workload that needs mass parallelization, and that's exactly what HPE's been doing in the supercompute world for 50 plus years. So it's huge at-scale compute, we are at the forefront of that industry. I mean, it was announced at Supercompute this week that HPE have the top three of the top 5 supercomputers in the world, and we take that technology and use the experience of optimizing the performance at that level and intellectual property and software and bring that into this new world of AI training, and we do that at massive scale. So it's something that we're very used to doing, and we've got a huge amount of customers at the moment that we're working on for training huge foundation models. But then equally, the market we see moving very, very fast towards inference, and what a huge opportunity that is. I mean, when I think about that, inference is really the outcome of the foundation models. It's the business outcome, and we are at the very, very early stages of that in terms of the applications that are going to create the demand for inference. And HPE again in that space is very focused on optimizing technology to create the best outcomes, the most efficient outcomes for our customers in many different ways. And I'll talk a little bit more about that, I think, as we go through the talk. But HPE is very, very central at the moment to this whole new emerging AI space.
Thank you. And Philip, I know your first CPU is more focused on HPC, but can you tell us more about what you're going to do in inference?
There is a lot more to say. Thanks for this. So first, to introduce Cyperl, we are the European company developing a high-performance microprocessor. This has been discussed this morning, but we want the Jupyter machine will be the CPU that will fuel it to be deployed in 2025. That's probably the first time a European company has been able to beat a bit American player on this area, and also for ARM to beat x86, the legacy solution. Now, the way we have developed this solution, it's with lots of embedded core, so ARM v1, and also lots of embedded memory, so-called HBM, so high bandwidth memory, which is directly within the package. So it means that we can deploy lots of embedded computing without talking to the external DDR5, which is usually very consuming. And let's say a couple months ago, when ChatGPT and everything related to inference AI started to boom everywhere, I pushed my guys to tweak a bit the architecture and to see how competitive we could be on inference AI. And now we're quite happy to say that when you have, let's say, more than 64 gigabytes of embedded memory within one chip, and that you can manage terabytes of data throughput in between cores and between embedded memory, yes, we are fine for inference AI, because we can store a full inference model within the chip, which means that in terms of computing efficiency, when you are not talking to DDR5, we can have some very, very interesting power figures. So for us, it's a go for inference AI.
Great to know. And when we talk about this, when we talk about inference, we talk about the fact that hardware is going to be changed. For now, we have a hardware which is very dense, very complex, very highly connected in one place. And then with inference, we will have the topic of being much more distributed infrastructure. What I'd like to know, maybe beginning by DDN, James, is that we know that everything goes with data, a lot of data. And when we talk about infrastructure distributed, how does it go for data?
Yeah, this is like a little panel about hardware. So let me talk about that a little bit. So we are a storage company. So I am interested in the CPUs and GPUs, and congratulations, by the way, on your new CPU. But of course, we're really interested in storage systems. Now, what's a storage system? It's really just a computer. It's got some flash, it's got a network, a CPU. It's just the shape of that storage, that computer is designed to put data and get data from more than anything else. And as we see data become more distributed, and particularly inference going to the edge, that means we need different shaped storage computers to manage that stuff. So in telcos, close to your mobile devices, very low latency using 5G and then 6G, we need to have these hardware pieces that are very small, very compact, very low power, and still very fast. And we're seeing, by the way, we're seeing a bunch of different vendors coming up with DPUs, data processing units. And it's like, it's just a computer on a chip, really, but it adds in a network, adds in the capability of adding in storage, and has CPU, because you always need a CPU somewhere. So we see a lot of DPUs in the world driving inference at the edge. And then at the core and in the cloud, we kind of need the opposite. We need very, very scalable, large-scale storage systems that are going to be optimized for maximum performance, maximum throughput, maximum IOPS. Because as we've seen this past year, the critical thing is kind of efficiency. It's very hard to get 10,000 GPUs or whatever it might be. They're very rare, very scarce, and they're very expensive. So there, the key for storage is how can you keep it all running at maximum efficiency? And the worst thing storage can do is make everything wait and burn energy and burn your capital costs. So I see the world of storage around AI really diversifying. So bigger things get bigger and the littler things get littler.
And on this thing about being littler and the power usage that you just talked about, can you, Philip, talk to us about what you are going to do on the design of the chips?
Yeah, this is also a complex topic. For this, we are used to talk about nanometer. Now, most of the industry for compute is moving beyond 3 nanometer. So it means that you just have a couple, let's say, atoms per transistor. So which is the way of designing the chip, it's even more complex. For a third generation, so the one that will be in Germany on Jupyter machine, we have embedded more than 60 billion transistors. Not talking about the memory. For the next one, in 3 nanometer, will be, let's say, more than 100 billion transistors. which gives you an idea of the density of compute you can have within one chip. And you are talking about sovereignty earlier on. It's also a good way, no comment for the, let's say, US authorities to control the export, because when they are talking now in terms of export law about computing density per square millimeter. So if you are beyond a specific threshold, you cannot sell to countries like China, for instance. If you are below this threshold, it's okay. But the lessons behind is that we are going to much more integration. When you're moving to deep node process, so beyond 3 nanometer, you consume far less per transistor. And for the experts, when you are, let's say, for such a design, when we are talking about a switch, so it means that a transistor which is switching, or gate which is switching from 0 to 1 or 1 to 0, in terms of energy, we are talking about picojoules per switch. And when you have 100 billion transistors on one chip and you're switching 3,000, let's say 3 billion times or 4 billion times a second, so the level of quantity you have to manage is huge. In 2 years, we'll talk, let's say, about something like more than 1,500 watts per chip. So it means that for, let's say, clouder like Scaleway, it's lots of energy to manage. For us, designing the chip, it's to manage all the supply, to supply to the chip. So there's still a lot to do, but that's definitely where everybody and Cypher is going.
Thank you. And talking about this, we talk about storage, we talk about chips, but there is infrastructure over it, servers. Anyway, we will need this. How HPE is going to go on this?
Well, I mean, you know, in terms of sustainability, it's a really important thing for us to be doing and to designing into our systems. You know, again, when you look at some of the core challenges around designing and architecting high performance compute, either in the training space or the inference space, you know, power, cooling, scale are all critical aspects, and to be able to cool these things is a major M&E challenge, and one that we put an awful lot of time into. And to that extent, you know, we have the greenest technology on the planet. When you look at supercomputing, the top 3 greenest computers in the world are HPE computers, and the reason for that is the way that we model out the design, the cooling, and optimize the performance of the technology that's in those supercomputers. And again, you know, you think about what those supercomputers do, and the sustainability outcomes that they create. And again, it's really fascinating. And then, you know, in the inference space, and in the more standardized AI modeling space, again, you know, we put an awful lot of intellectual property into designing systems that create highly efficient power outcomes. In fact, you know, our most modern or most recent system, which we operate with the H100s, the DX6500, that operates at least 40% of the power efficiency of the DGX systems themselves. So, you know, we can gain huge energy efficiency from the knowledge and the way that we put these things together. And when you think about that in terms of sustainability, when we're talking about coupling together thousands and thousands of H100s in one place to do one training workload, that's a major impact, both in terms of cost and electricity. So yeah, I mean, that's our opinion on that.
Thank you. And Jean, maybe you could talk to us about how quantum is going to go in AI in this topic, that you have the same thing as GPU. It's imagined as quantum is big, bulky, hyper infrastructure. How do you go to inference, or how does it go? We go from quantum to AI now.
So yes, so it's clear that the systems are big, bulky. So just first word on Candela. So we are not very known in the AI world because we are quantum. So we are doing quantum computer with single photon. So the quantum particle that we are using to make computation is one single photon. So something that has one attojoule of energy, and we are computing with this level of particle. So these systems are very rare in the world, not only photonic, but there is a lot of other system, quantum systems. They are very rare. There is less than 100 systems in the world that are available online. And we are trying to make that available, and it's one of the things that we are really trying to do. And one thing we did and we announced today was also to make available the quantum as a service at Scaleway, because these systems that are super rare, we need to make them available so that people can start learning and doing things with them. So quantum and AI. So first thing we need to know is that there is a promise in quantum that that quantum will come with a kind of unprecedented computing power. It doesn't mean that we'll be doing things that we do today faster, but it will be doing things that we cannot do, basically. So there is a real shift of paradigm here, and there is a real match with AI for two reasons. First, because there is already some evidence on the systems that are available today with relatively small scale that quantum can boost AI. And just to give some idea and order of magnitude, with 20 qubits, 20 photonic qubits, we are manipulating a space, a computing space that is bigger than ChatGPT with 20 photonic qubits. So we have a totally different paradigm where AI obviously needs to go, because we are also manipulating this huge space. And there is another reason why to go to AI now with to quantum now with AI, is that we are kind of lucky today that all the quantum system available in the world today can be simulated with classical AI, and which is an opportunity because we are developing for the moment system that we can simulate. So we are using AI to develop algorithm, and at the same time to improve the design of the quantum chips. And we know that this won't hold for a long time, because in 2-3 years, the classical computing power will not be enough to simulate quantum. So quantum will be on its own. So for the moment, it's important that quantum and AI play together.
Thank you very much. Mark was talking about this, and you talked about this too, about power. I have a real bad moment for me. It's like pronouncing a Dutch name. So please, I'm sorry if someone is Dutch here. Alex de Vries from Amsterdam, from the School of Business and Economics, just published an article about the power consumption of AI. As it seems, in 2027, AI will consume as much power as Sweden or Netherlands. So it makes it like a country of the G20 in terms of power consumption. Nothing to say more. I think we understand the issue for everyone. James, can you tell us more? Because of course, there is a lot of storage, and storage will use a lot of power too.
Yeah, so we do talk about this a lot with customers, but it's not quite the story you might expect, because CPUs and GPUs are the power-hungry things. Drives aren't really in the same scale. So in a data center, the storage system is probably going to consume less than 1/20 of the overall power. But I kind of think Jensen Huang, who started off this conference today, he's got the right idea. In order to reduce our power consumption, we've got to do this thing which he calls accelerated computing, which really means integrating right across the whole stack. So we no longer have an application, a CPU, a network, a storage device, blah, blah. These things are hugely interconnected. So the application's talking in some way directly to the storage is talking in some way directly to the network. Everything's transferring information to give you absolute maximum optimization right through the stack. And we do this today, by the way. So about 2 years ago, NVIDIA came up with GPU Direct, allow us to RDMA, that means sort of magically fast move data from storage into the GPU memory. And then there's other things we've done to connect into that stack to basically take away all the inefficiencies. And that's the easiest gain, is huge integration up and down the stack so that we don't waste any of these cycles. And that's already given us like 10, 100, even 1,000x gains, especially at the application layer, when the application starts talking directly to the individual hardware components through open APIs, then things can get hugely efficient. But it is a big story. We've got to sort it out, and it is a little bit upsetting that AI is going to consume so much power. So I suppose the big positive side, it might be able to resolve some of the problems associated with our energy consumption as well.
Thank you, thank you. And Jean, do you think that quantum AI can change in this area?
Yes, definitely. So there is two things to know about quantum: is that the growth of power with computing power of quantum is exponential, meaning that when you have one system with 20 qubits, you add 1 qubit, you double the power of the system, which is totally different than the classical system where we want to double the power, you put to a computer, or you are a bit smart and you can make a bit better, but basically it's linear versus exponential. So here we have a gain. The second thing to know about quantum is that we are quantum. Every particle for our body are quantum, but we are not quantum. We are not directed by the law of quantum because all the particles interact together and they are making the quantum state what you call decohere. So to keep a quantum state and to be able to make some quantum computation, we need to be absolutely sure that there is no decoherence, which means that the particle needs to be isolated from everything. And in that case, it means that it's the kind of enemy of energy. If we have energy, we cannot have quantum computing. It's kind of the two sides. So the other way around, when we have a quantum computer, we'll have something that doesn't use a lot of energy. I just want to, because it's always a bit complicated to talk about energy without trying to make some greenwashing, we need to be careful here because first, the energy cost, the energy budget of a quantum computer is what I say, the core should not use energy, otherwise we are talking about attojoule. But at the same time, everything around will consume energy, and this, at the end, we need to be careful of what will be the part. But the core should not consume energy to be able to work as a quantum. So this is very important to keep in mind when we are thinking about that. And the second point we need to keep in mind is that with this unprecedented computing power, there might be some rebound effect that appears every time that we make some progress. People will use that computing power even more. So maybe but it's more depending on how human will be using this new technology.
Thank you. And talking about linearity and not exponential, how does Sipol is going to manage this sustainable issue?
So you're absolutely right. We have a problem. So one of the ways to solve it, I said, is that to move to deep node process, which means that the chips will have a much more higher density of compute per chip, which means also that the chips will be much more expensive. So be ready in HPE, DDN to afford the cost. But that's life. You have to pay for development. Yes, I know. Sorry for that. And if we take analogy with what happened in the smartphone business, let's say for the past 10 years, a smartphone can last something like 1 day on a battery. But also during the same period of time, the computing power you have on the smartphone has been, let's say, multiplied by 10x, 20x, something like this, with Android getting more complex or much more application. So let's say, smartphone business has been able to successfully manage the growth of computing power. So of course, the better technologies in terms of battery, much more better chips to compute. And as you said earlier on, so it's system level architecture, but it's also new architecture within the chip. And one of the ways to do it, and I know that Scaleway is quite keen on it, and we're quite keen on it also, is in terms of new instruction set and work on ARM-based architecture, which is and ARM is coming from the smartphone, so battery management and a good instruction set, and that's what we are doing, among others. And your two sponsors today are also, let's say, quite ARM-centric. That's one of the solutions.
Talking about Scaleway announcement, we already this morning talked about announcement about quantum. It's really another way of thinking AI, and I will be really interested to know how quantum is going to revolutionize AI exactly.
So we don't know everything yet, but there is a lot of evidence that this will bring new things. Like, for instance, we call that quantum embeddings. So embeddings, you are projecting data in a big space. Here we are talking about a huge space that doesn't follow any of the linear rules of transfer that you can get in a neural network. So here we have these quantum embeddings that could be something totally different, that will be a part of a hybrid system where there will be GPU and QPU working together. There is also other evidence, like boosting of the convergence time. We see that because and thanks to the parallel effect that we can do with quantum, we are able to explore far more the space when you are training a neural network, and then get a gain in the convergence speed in totally classical AI. So not everything is proven yet and tested, but there is a lot of different perspectives where we can see that quantum and GPU, intelligent GPU, will work together to improve the algorithm that we have today.
Jean is talking all the time about exponential, and we know we are consuming data. So if we are consuming data on an exponential way, how is the DNN going to manage this?
I guess sell more storage systems. Yeah, I mean, it has been exponential for a long time. I mean, I've been at my company for 12 years, and that curve of data growth rate has been exponential. There's no change. Fortunately, with the advent of Flash, we've hit like the Moore's law in CPU. We kind of with traditional HDD technology, we kind of just about hit the buffers there. We kind of every year we get another 2 terabytes, 2 terabytes, 2 terabytes, and it grows like this. Whereas Flash is doubling. So right now we've got 60 terabyte Flash devices. End of next year we'll have 120 terabyte Flash devices. So for the short term at least, we're on a very strong exponential curve in terms of the density of data we can store at reasonably low cost and low power in these systems. So I guess long may that continue. Of course, we do have, just like quantum's coming to potentially revolutionize AI, there are other technologies in storage which might revolutionize our world. There's new organic storage chips, for example, which are going to bring higher density potentially. It's a little bit far out, but I think we have maybe a good 3-4 years, a bit speculative, of continued reasonably exponential growth in the Flash.
Okay, thank you. And HPE, we know you are always working on the next generation. What is happening on your side, looking at quantum?
Well, I mean, for us, the next generation is continuing to create the world's fastest supercomputers at the very top end. But it's also about democratizing that and bringing the expertise that we have and the intellectual property that we have at the very top of the market into the general market. So, you're seeing innovations from HPE, such as Slingshot's a good example. Slingshot is the network fabric that manages these millions and millions of cores that are in supercomputers. It manages the performance of the network to optimize to the overall throughput. That technology we're bringing into our core kind of Preligens range. And again, when you think about Moore's law, you think about how performance will grow over time and how fast it's grown already. You need innovations like that in core technology to enable the things that are going to need to get done to be done in a more general space. So, for us, it's about driving innovation from the top down. It's also about developing software tooling that increases the efficiency of the system. Because again, if you think about the capital cost of this, a supercomputer at the top will cost 200, 400, 600 million euros. With optimization, with software tooling, optimization around expertise in managing the application performance with the technology, you can increase the efficiency of a system by 10, 20, 20%. And 10% of 600 is a lot of money and a lot of capital efficiency, and a lot of extra things that you could do with that technology. So we're about optimizing this architecture to enable customers to get the most value out of it.
And on Cypher side, Jean was talking about the fact that we will have an association of GPU and quantum in the future. How do you see this at Cypher?
Yeah, very good point. In fact, we see quantum as an accelerator. So for us, interfacing with a quantum computer or quantum accelerator, it's equivalent to interfacing with any kind of accelerator. Part of not the hype, but let's say the quantum processing, the big boom was something like 2 years ago when it was a global awareness that quantum will be everywhere. And it's still in, and it's fair, but it's going to be surrounded by standard computing, standard chips, which is so good for my business. So the interfaces exist. There are multiple, let's say PCI, CXL, or plenty of standards which arrive to do this kind of interconnect. But the way I see let's say big HPC or even HPC for AI, it's going to be heterogeneous. So you'll have multiple forms of acceleration. depending on the workload they will have. You will have clusters of CPU, and that's what, for instance, happened in Germany. What we will see also, and this unfortunately for us in Europe, this happens in the GAFAM in US, they can develop their own chips, which are really targeted for their own need in terms of TPU or DPU or something like this. So in Europe, it's a bit more complex because we don't have clouder or hyperscaler at this level of scale that can afford such a design, but we are, let's say, happy to help them. And what you will see also in terms of architecture, and to go back to the energy savings, so for the machine learning, the big heavy machine, it's clear that NVIDIA is far ahead of this, but in terms of inference, which is part of the deal, because not only a question of building the model, after you need to use it, and for this you will see much more and more chips which are really dedicated for inferences, and there are, let's say, a couple candidates for this, including us.
Thank you. So thank you for the four of you to give us all this information. We are very proud at Scaleway to work with all of you, and this is great to see this. Maybe before closing this panel, we could have a word from each of you about this future, inference, quantum, sustainability. What is your last word, vision about this?
My last word would be just an anecdote. I was lucky to work in AI, in natural language processing, in 2016 when the paper from Google, Attention is all you need, appeared. So my engineer came immediately and said, what should we do? Should we try to do it? And we did. And immediately it works. And I see exactly the same effect today. There was something we knew, that AI was to become something big with natural language processing. And ChatGPT is the proof today. And we are at the same stage in quantum today. We have small system. We know that there is something. There is missing the little thing that will go ahead, but we should work on that. And my point is that it's time to start.
I'd like to conclude a different way, because you started with sovereignty. I'd like to conclude on sovereignty myself. 20 years ago in Europe, they completely missed the, let's say, the web business, the cloud business. You see in which position are the GAFAM today. Now for AI and also semiconductor, if we don't want to miss the second chance, we have to do it now and do it quickly. If not, it's going to be, let's say, US tech everywhere again. And you got a good demo this morning.
Exactly.
I guess my last comment would be, Sam, it sounds maybe a bit trite, but AI is absolutely changing the world, and it's changing the way that we will live and that we will work. And there's no doubt that we're, I think, right at the beginning of enjoying the benefits and the outcomes of this. As I say, when you go from training to inference, you're going to where you make a difference in society, where you make a difference to people, and I think we're right at the beginning of that journey. So just incredibly excited to see that. Very lucky and privileged to be a part of that journey. It's been amazing today actually seeing and talking to some of the application providers, because again, to me, that's where the outcomes are made from this stuff, and where you start making a difference to the consumer and to the user. So yeah, just incredibly excited to be part of it, and looking forward to the road ahead.
Yep, nothing to disagree with there. I'm in life for having fun, and this sort of AI revolution we've been going through the past few years is really fun, especially in the industry. So it's been very exciting, kind of surprising at times, and that's what I'm here for. And now with quantum coming along, I did a PhD in quantum physics about 30 years ago. So I'm kind of looking forward to be able to talk about that stuff again, and hope it comes to fruition in the next couple of years.
Thank you very much. We can impose, I think.
All right, we have reached the end of this day. Thank you so very much, all of you, for joining us today. Have a great evening. All right, online, thank you so very much for tuning in. And in person, I'd love to invite you all